Welcome, everybody. Welcome to our audience online. Today, we're here for Insights at Questrom, the emerging impact of AI on customer engagement. Big topic. Our panel will make introductions in a minute. So myself, I'm Peter Howard. I'm Executive Director of the Digital Business Institute here at Questrom School of Business, sponsoring this event. My co-host, David Epstein, the Executive Director of the Sicilo Institute for Ethics in the Global Economy. He's also M.S. Fakhani Visiting Professor in Global Leadership. So what I'll do some housekeeping, go through the agenda. We'll talk about how to manage Q&A on our hybrid environment today, online and live. And say a few comments about our topic. David will say a few interesting comments about our topic to set us up, and then we'll kick right off, okay? So our exciting agenda today, our welcome and introduction, we have an industry perspective from our special guest, Jivan Dugampudi, partner AI and analytics for IBM Consulting. Welcome, Jivan. Where did he go? Oh, there he is. Yep. Then we'll have three back-to-back presentations by faculty. DK Lee, our Associate Professor of Management and Info Systems, will present one topic. Gordon Birch will present the social design of AI-enabled autonomous agents. He's our Associate Professor in Management also. And Avi Sedman will present something on digital health, right, and the successful use of AI. So those should be exciting, thought-provoking presentations, which will set us up after a brief coffee break for a panel discussion where we'll have everybody up added with Michelle Schell, our visiting assistant professor of ops and tech management. Welcome, Michelle. And Maisie Zhu, who I think is not here yet, will be coming shortly, assistant professor of AI systems. So, and David Epstein will be joining that panel as well. I'll be trying to moderate. Yes? Oh, Maisie, I am so sorry. Welcome. Thank you. I missed you on the left there. It's my peripheral vision. But anyway, so here is where we really encourage a lot of participation. We'll ask you to just audience here, ask questions, but we'll ask you to ask them on the mic so people can hear online. Online, we have a method, which I will address right now, on how to ask questions. So hopefully everyone can see this. You can scan the QR code now or use the link to enter your questions. I have an iPad they will go to, and I'll go through the questions and try to moderate. But we're hoping it will be a good open discussion on these topics, the implications for the future, and then we'll try to wrap it up at the end. So somewhat informal, but it should be fun. With that said, David.
Okay. It's on. Okay. All right. I thought for a lighter way to start out, I was working last night at my dining room table with my granddaughter, and she wanted to read my introduction, so I recorded her to do it, and I thought I would have that. So.
Good morning, and welcome to this important conference on the use of AI for customer engagement. As the Executive Director of the Sicilo Institute for Ethics in the Global Economy, I am deeply committed to exploring the ethical implications of technology in our rapidly changing world. The use of AI in customer engagement presents complex challenges and opportunities, and it is crucial that we approach these questions with a deep understanding of the ethical considerations involved. Today, we bring together experts from various fields to delve into these critical questions and to explore the role of AI in customer engagement from a variety of perspectives. I am honored to welcome you all to this conference, and I look forward to a productive and thought-provoking day of discussion and analysis.
Okay, I lied. This is, let's see, the AI generated voice was a Victoria from Revoicer. There is, I don't have any So the picture here was generated by DALL-E 2 completely, and all of the script was done by ChatGPT without any modification. So I thought I did a pretty good job. All right, so I guess although AI has been around for a long time, and in the research community, as DK pointed out to me, many years worth of research and work has been done, and it's been discussed a lot in philosophy and in different places and sociology. It really hasn't risen to the level that it has in the last couple of months due to now the availability and the opportunity to use things like ChatGPT and DALL-E 2 and all these other ones that's open to the public for free and for use. And everybody has been, anybody who has not been working in AI before is totally surprised at how advanced it is and how scary it might be. So AI, of course, in business goes much deeper than just the sensational things that you see here. Although these are certainly things that we're going to be dealing with. It goes deeper. We've been using AI in business for a while. With that, depth becomes some responsibility. And so one of the things that I want to make sure that we talk about, not only the capabilities of AI, but I'd like to talk about some of the ethical implications of AI. So I'll be doing that along with, hopefully, there will be some discussion that we come out of that. So before we begin, I'd like to just acknowledge that Boston University is on land that is part of the Wampanoag and Massachusetts Peoples Territory. We honor and respect their history and continued efforts of the Native and Indigenous community leaders to preserve that heritage. Today, Boston is still the home of Indigenous people, including the Mashpee Wampanoag and the Wampanoag tribe of Gayhead Aquinas. So with that, thank you, and I'll give it back to Pete.
Excuse me. Thank you, Dave. Well, great. So clearly AI is a huge topic. In fact, some research I've looked at indicates that polls and surveys of CIOs and CEOs, it's, if not the top, one of the top 5, certainly priorities for 2023 coming up. Beating out things like security, things like certainly metaverse was sort of flash and still needs time to grow. And other major priorities that have been on the forefront. So it's big, but question is, what is it? How will it be applicable? And what are the ethical implications? So let's get started in our exploration. Jivan.
I do. Yes. Hello. Hello. Okay. Good. Do I need to use this, or can you all hear me okay? Oh, for the film. Sorry. Okay. All right. Good afternoon, everyone. My name is Jeevan Dugimpudi. I'm a partner within IBM Consulting's data and AI practice. So I'm part of a vertical that supports 3 different industries. We support a lot of our healthcare clients, like payers, providers, and the likes. Life sciences, which includes a lot of our biopharma, med devices, animal health clients, and state and local governments. So state of Massachusetts, state of Virginia, any number of states, because a lot of the states also have a lot of healthcare budgets these days on how they manage that. So we do a lot of work in that space. So I lead our AI and analytics practice for those 3 verticals. And that's the position that I'm coming from here for the next 20, 25 minutes here. Before IBM, I spent some time at AWS, Amazon, and prior to that, spent about a decade at Deloitte, all in the data science space. I was joking with somebody earlier, I think Avi, that when I started my career about 22 years ago, it was just called simple, plain mathematics. It's just the same kind of algorithms are now called different terms. But anyway, so what I wanted to start with is, before I jump into the content itself, what I wanted to talk to you guys about is some of the case studies, real world case studies, where AI is actually driving measurable benefits through the work that we are delivering. I'm sure everybody is doing that, but these are just examples that are close to the work that we are doing. And this just helps you understand the power of AI and how it is actually driving value within various sectors and enterprises, right? So I pulled together 3 different examples. One is from government, one is from healthcare, another from agriculture. So 3 different examples, and then we'll get into some of the content. So the first example, this one is from Department of Veteran Affairs. We do a lot of work with the VA, and VBA is part of VA, the Veterans Benefits Administration. They do a lot of benefits administrations for the veterans in the US. So think of healthcare claims, pharmaceutical claims. All of those claims are managed by VBA for the veterans. The journey with them for us started back in 2019 when they annually receive probably about 14 to 15 million just plain old packets, right? Just paper-based packets. If as a veteran, if you want to get a benefit for a pharmaceutical claim, you'll have to fill in a form, mail it to a PO box, and that's really goes and starts the process. There are these like conveyor belts of people close to 3 football fields, at least when it was starting back in 2019, where people literally process every step along the way. It would take anywhere from 15 to 30 days to process one piece of paper. To adjudicate a claim, you're probably looking at about a month of time, right? So that was the baseline where we started this project with, right? Now, over a period of time, we started a small MVP and then that scaled into production. But now we have been on this journey with them for about 3 years, where we built an end-to-end data pipeline. We started with ingestion of all these paper-based applications. We applied OCR++ techniques and computer vision on top of that to extract the relevant information from these claims forms. We have a machine learning algorithm that classifies and then decides if that claim can be auto-adjudicated or it has to be passed to a human for review. And then there is a portal, a front-end portal that basically this human reviewer can look at to adjudicate the claim, the remaining claims. So this entire pipeline was built for them and it's currently being used by VBA. The net benefit of this, by the way, is at the bottom, right? We process today about 20,000 claim transactions per day today. This may be a little dated, but this is over those numbers. 70% of those claims are auto-adjudicated. There's no human touch at all, like just straight through processing. We were able to capture about 400 plus variations of various forms. You'd be surprised how the same claim form is like in different formats. So for an OCR engine to recognize all these forms, you have to bake that, build those models in. There are about 400 different variations of those claims forms that the engine, the entire platform now looks at. We were able to reduce for as I was saying, it used to take about a month to adjudicate some of the claims. For at least some of those straight through claims, we are now able to adjudicate in less than 30 minutes after it gets ingested. So that's the power of some of these. And last thing is we were able to free up about 200 agents that can now use their time to basically do some higher value things, I guess, tasks. There were really 3 football fields worth of people that were working on this. I think now it's down to 1 football field. But really, that is one example of how we are actually delivering value through AI, right? Again, this is not just AI. This is one thing that is a big lesson for me. When we talk about AI, we think that data is very nice and ready for us to do AI. There is a lot of upfront processing that needs to happen for that AI models to be ready for production. So all that data fabric and everything, we ended up building it for them. So that's from the federal space. This is the healthcare example. So all of us have been living through COVID over the last 2 to 3 years. This is for a healthcare payer. As COVID hit, their call volumes to their call centers spiked 10 to 50 times. And people, members, customers, caregivers, everybody were calling their 1-800 numbers to ask questions around vaccines, questions around scheduling, questions around side effects, comorbid conditions, wide range of tasks. Their call volumes really spiked, right? The net of that is the average hold times on some of these calls were well over 90 minutes. And that was unsustainable for them. So they came to us and we basically said, can we use AI to at least alleviate some of this pain in the short term? So I'm sure most of you know voice virtual agents. So we were able to deploy a voice virtual agent that sits right after their IVR system. And as soon as a person calls the 1-800 number, we meaning the voice virtual agent, the AI agent actually picks it up. And you can actually talk to the agent as if you're talking to a human being. You don't have to go through 1, 2, 3, 4 IVR thing. You can just directly ask, what are you calling about? It understands the language, it understands the intent of your call and digresses the call directly to the intent that you are calling about. And then for those cases where it really had to be transferred to an agent, it would then transfer. We were able to deploy this in less than 3 weeks. This was at the peak of COVID. And over a period of 4 months, the IVR system, not the IVR, the voice virtual agent has been able to handle about 16 million calls over a 4-month period. And out of which about 65 to 70% of them were never even transferred to an agent. It was fully contained within the voice virtual agent itself. Now, like this is again, I mean, these are the kind of benefits that we are talking about, right? There are the primary benefits are what you see here, but again, cost, savings, and associated improvement on personalized interactions with your members are secondary benefits. Scheduling was a huge benefit as well. I'm sure if any one of you are calling to get a COVID scheduling during 2 years ago, majority of them were on hold for half an hour or longer. So this is the last example. This is from Europe. So does anyone know Yara by any chance? Have you heard of Yara? You did. Okay, great. How was your experience? Yeah, they are actually an innovator in agri-tech. They're a fertilizer company, but they have realized the power of using fertilizer to improve productivity for farming. They have a mission that the amount of hectares of land that we have on Earth is not enough to feed the growing population of Earth. We are supposed to hit like 9 billion population by 2050, and there is not enough land on Earth to actually feed all of them. So one of the sustainable missions that they went after about 4 years ago is, can we improve the productivity of the 1 acre of land that our farmers are actually using to grow the various food? So what they ended up doing is they have about 600,000 or so farmers that they currently support across the world. That is one beautiful thing about these guys is their products are being used in Australia, Brazil, US, a lot of Northeast Europe. So they are actually very well covered geographically in that sense. So over a period of time, we ended up deploying IoT devices on the various farmers' land. And it can actually understand build the entire streaming from IoT devices to the cloud, build the entire data platform for the farmer, and then built out a user dashboard that either the farmer can access through like a simple web portal or an iPad app. But what does the farmer really get? The farmer gets a couple of most important things. One is what is called as a weather as a service. So the farmer, for that hyper specialized region that they have, they could actually look at historical weather patterns and also predicted weather patterns for the next 4 to 6 months down to an hourly level, right? So that is a weather as a service. So that is one service that they can get through this. The second is crop yield as a service, which is how much yield from that 1 hectare of land can that farmer expect based on the fertilizer patterns, based on the weather patterns, based on the environmental factors, based on the humidity levels in the farm, all of those factors combined, there is an algorithm that basically says, here is the expected yield that you can expect for your farm for the next 4 to 6 months. So crop yield as a service is part of this platform, and this is currently available to about 600,000 farmers. This particular thing, the goal of this right now is to cover about 7% of world's hectares. So this platform is about 6% right now. The goal is about 7%, which we are fairly confident of going. 7% of hectares of land that is available for farming will be on this platform by summer of this year. And they just went to WHO for thinking about how to grow beyond that as well. Now, again, I just wanted to start with these 3 examples, right? Because these are real concrete examples that again, we see daily add value on a day-to-day basis using data and AI. Now, let's go to the boring stuff. I mean, I think David was talking about it just now, right? There is, AI has been around for a long time. I mean, it's just how we define AI. The way that we have been looking at it, and we have been talking to our clients is, anything that we call AI that mimics human cognition. Think of it that way, right? It could be heuristics, it could be algorithms, right? But anything that a human would do and anything that would mimic a human's cognition is really what we call AI. And it's been around for a long time. A subset of AI is what we call as machine learning, where I think this is the recent phenomenon, right? Where you have a historical training data set, you have historical understanding of what the expected predictions are, and then you build an algorithm to forecast your future. A more recent one is deep learning, which is a subset of machine learning that uses artificial neural networks to basically do the same type of work that would be done as in your traditional machine learning work. But that actually, in a way, spurred what we see as the AI revolution in the last 8 to 10 years. I mean, it really started with the CNN paper back in 2012, I guess. But what has grown in the deep neural network age is it's not just the algorithms, it's also the availability of data and the availability of compute. It's so easy to spin up a GPU now and then run your algorithms and train your algorithms. You don't need to have a supercomputer to do that, because you can just spin it up on Amazon or GCP or Microsoft Cloud so much easier than what we were able to do just about 10 years ago. So where do I see personally, right? I think we are in this era now where, I mean, ChatGPT is a great example now, right? There are these foundation models that are everywhere that are serving a number of these purposes. But where I see this actually bringing value is the verticalization of those foundation models, right? You take an AI and then you say, what is it used for? AI and something is really where we see a lot of applications. So for example, the first example is AI and customer care. So this is where you see the example of call centers and voice virtual agents that I mentioned earlier. This is how do you drive personalized support and personalized interactions with your members, customers through AI. The second is AI is not just transforming the front-end experiences, it's actually transforming even the back-end experiences. You would be surprised how much, like the Veterans Administration is a back-end example. Similarly, in every one of our large enterprises, we have invoice processing, like simple stuff like that. Invoices take so much human labor and cost. And those are the kind of things that are also being transformed. IT help desk is a great example, right? HR help desk. These are the kind of things that are completely being transformed by AI. Again, I say AI and BPO, right? Marketing and sales is the third vertical. I mean, this is the age-old problem, right? Recommendation engines, personalization, your marketing mix models, all of those are, I mean, this was the original use of predictive analytics and data mining and AI. We are also seeing a lot of HR talent applications for AI, especially over the last 2 years, where we have seen a lot of talent gaps within companies and the fight for talent in that sense. So we have seen a lot of work with companies where they're basically scanning through the resumes of their employees and understanding what kind of skills base do they have today within their employees. But as their organization is transforming, where do they need to go from a skill standpoint, right? Where are they today versus where they want to go? And then what is the gap and how do they fill the gap, right? So there are a lot of applications like that for AI that we are continuously being working on as well. One good example for HR, by the way, within, I don't know if you know this, but within IBM, we have this thing called Ask HR. I've been with IBM for about 2.5 years. I've never called our employee call center till date. 90+% of our employee transactions are handled digitally, fully. There are about 27 different chatbots that handle transactions like my payroll, my vacation, my workday transactions. Everything is handled for you. Very few edge cases where you really want to talk to a customer, then we can call an agent or open a support ticket. But so far in the last 2.5 years, I have not had a situation where I had to talk to somebody, because those things are getting very, very smart these days. So I think this is just a replay of what I mentioned in the previous slide, but really where I see areas of like growth and opportunity are, first is language models, ability to read and understand language. Language meaning not just English, every other language, right? The language. So that is an area. And we'll continue to see verticalization of this, right? So taking ChatGPT and applying it to healthcare, applying it to insurance, applying it to, so we'll continue to see verticalization in that content intelligence space. Vision is another example. There was an example recently, and we were doing a small POC with actually a fast food chain. We put an edge camera in front of a fryer that fries French fries. And as the drive-through orders would come in, it would look at number of French fries on your in your fryer and say, indicate to the guy basically, oh, the number of fries that you have in the fryer are actually less than what the demand is right outside your door. It would send like these signals. There are red, yellow. It was simple enough for them to understand you need to put more fries. There's a simple AI model that was basically just looking at the number of fries and then seeing if that is sufficient to capture the demand that is out there. So there's a lot of work happening in the vision space also. That's just one example of how we have been seeing it. AI at scale, again, this may not be the glamorous side of AI. What I mean by AI at scale is a lot of enterprises are also challenged by their ability to scale their AI operations across their various units. So you'll hear this term called ML ops being used frequently, or machine learning ops. This is where you start to mix engineering principles with data science principles, right? And start to like bridge the two between. And that is an area that will continue to grow from a talent perspective, from a job market perspective, at least in the next 2 to 5 years. Because a lot of people have enough data science talent, where they are struggling is operational side of that. And that is where we do a lot of work in the ML ops space. And I just mentioned cognitive care. This is the whole conversational AI side. I mean, honestly, at the end of the day, nothing is possible if you don't have a unified data fabric, right? Because at the end of the day, you need to have a single view of your customer that goes end to end. And today, in majority of the enterprises, unless you are digitally native business, your data is logged in your silos, right? So creating a unified data fabric that cuts across your organizational silos is really, really where, again, as a data scientist, I started my career more on the data science side, but now I'm spending a lot of time here because everybody is challenged on just creating a unified data fabric. Again, I mean, from a value perspective, I think I don't want to spend too much time here. Increasing effectiveness of your current operations, reducing cost, creating net new businesses, net new revenue streams. these are just hard benefits, right? There are so many softer benefits, but these are just hard benefits that AI is actually driving. Now, I want to pivot a little bit and the last few things, because with increased prevalence of AI also comes responsibility on how you deploy these systems, right? So this is where I think this whole trustworthy, responsible AI is increasingly becoming relevant. I think it was just a year ago, I believe, Apple introduced their Apple Card with Goldman Sachs. I think some of you may know this. A husband and a wife, same socioeconomic profile, same income levels, same net worth. They applied for the credit card. Husband ended up getting a credit limit of 15,000, 20,000, somewhere in that range. Wife ended up getting $5,000 credit limit. The only difference between the two is gender, right? It was immediately scrapped. They had to go redo that algorithm that gave them that model. This is just the most recent example. I'm sure there are others, right? Amazon's recruiting algorithm was one of them. There are a number of examples like that. There are these cognitive biases that are inherent, but then below the iceberg, there are also so many of these biases that we as data scientists need to take care of as we deploy. And I think that goes to brand reputation. We are also seeing, because of that increased regulation, White House just announced a responsible AI handbook. I think it came about 2 months ago. It has some pretty good background on what are some of the high-level guidelines. Second, these are just, Europe is always ahead of us in terms of giving these, whether it is through GDPR or responsible AI practices. I've always seen like Europe is much ahead of US in terms of like these responsible AI practices. But it was good to see actually White House also releasing some guidance in how we actually deploy these systems. The complexity is also increasing, as you know. I mean, our models are increasing, complexity is increasing. So the number of people that are using it is increasing. So, and honestly, the last one is we have seen the last 2 or 3 years the focus on social justice. So as we think about it, not just from the hard side of things, there also has to be some ways that we look at, are we inherently propagating the biases that used to exist, but we have to somehow take care of that in our deployments. So I think aspects of, as practitioners of AI or builders of the future, my ask of you is to focus on some of these aspects of responsible AI or trustworthy AI practices. Right? Focus on fairness. Fairness is nothing but, are certain underprivileged parts of your data set getting advantaged or disadvantaged, right? Just making sure that those biases are there. Robustness. There are so many edge cases, and these edge cases are what gets all the press, right? So making sure that your models can handle all sorts of edge cases and all sorts of cases, right? Robustness is very important. Privacy, I think this is a continued debate. Who owns the data? Who owns the models? Who owns the algorithms? Who owns the decisions? All of that has to be properly documented ahead of deploying any AI system these days. Explainability, I mean, I've done some of my earliest work was in insurance. Insurance had explainability way back, like 20 years ago. They said, if you are using generalized linear models for your underwriting, you need to know why the models were actually making a certain decision. There had to be certain reason codes behind your behind the models themselves. So explainability has been around for a while, but now it's become increasingly important. Obviously, transparency, right? Transparency meaning you'd be surprised how many people have actually built the models and they trashed their training data set, right? If you want to just rebuild that model after 2 years, the training data set does not even exist, right? So that is where transparency of how you built the models, how do you did the entire pipeline, saving all of that is so much more important these days, because you would have to replicate that for audit purposes or other purposes in the future. So this is how we do our trustworthy AI models. I mean, this is very similar to what majority of the industry does, again, to be honest. You start with a vision, understand all these various pillars that will be used on how actually think about the end in mind and then work backwards from there, right, to your vision, right? put that as part of your vision, then break your big vision for the future into smaller use cases. And that is where your use case planning comes up. And then once you have your use case, then go search for the data that will help your use case. So, and then once you use your data, once you get your data, then you start to build your models. And then once your models are built, tested, validated, make sure all of your trustworthy AI practices are there, then you go about deployment. This is where operational side of it comes in. And last piece of it is ongoing trust. I mean, as things change, you have to continuously continuously monitor your data for a drift. Your data can change or your models can change. How do you establish a product? Make sure that both the model drift as well as data drift can be captured through your pipelines. Honestly, this is my last slide. I think what I just wanted to do here is just my own personal learnings of being in this area for 22 years now. You'd be surprised how many times we look at it through our lens of, this is a data science problem. This is a engineering problem, but never keep our end user in mind, right? So what I'm trying to say in that first thing is always don't have a nail looking for a hammer. Always have the problem in mind, the end user experience in mind, end user in mind, and then work backwards from there to your problem, right? You'd be surprised how that is still not prevalent, and it's a common problem. Second bullet is just, I've been in this space 22 years. I've seen so many changes. Be ready to be uncomfortable, right? There, as a single person or as a group too, it's hard to keep up with the pace of changes that are happening in the industry. So learn from each other, be curious, but at the same time, be ready to be uncomfortable as you work with your stakeholders. And lastly, to be very, very successful, I think you need to build your trust with all the people that are using AI systems generally. So bring them into the mix as you are designing. Let them be part of your design and build. And the most successful teams, engagements that I've seen, have a strategist, have a UX developer, has a machine learning engineer, has a data scientist, has a business person, everybody working together in a squad to build and deploy. So be ready to build your squads in such a way that you bring that diverse skills and diverse talent. So with that, I think that's my last one. I don't know how to get out of this. Thank you.
Thank you. Well, hold on, Jivan. I think we have, why don't we take a couple questions now? I'd like to save, more questions for our roundtable at the end, which should be very robust, but any immediate questions? Yes.
So excellent presentation. Thank you. I'm focused on healthcare, and AI is a distinct interest of mine. So I'm curious, if you look towards the future, which is what AI is supposed to do, where do you see the evolution of AI in healthcare?
I think we'll continue to see proliferation of language models. That is, you could see it as a variation of the foundation models like ChatGPT, but there is so much unstructured data in healthcare these days. I mean, you all know that's still untapped. By some standards, there is like 65–70% of the data is still sitting in unstructured data sources. 80. Oh, thank you. So I think that verticalization will be one big area of growth for AI in healthcare. The other areas that I see is continue to see improved personalized experiences through, it could be through your cognitive care type of capabilities where you are driving more personalization and personalized recommendation to your members or patients or HCPs, right? And that could be through techniques like voice virtual agents or conversational AI, or that could be through digital health, where you do not even potentially have to go to a doctor. It could be telehealth. and how do you embed some of those experiences through that? That's one. I have also seen pilots where, as you know, our physicians are also overburdened significantly. So, and a lot of that is coming from the administrative overhead that they have to do post a care or post a visit, because they have to put all that into their EHR system, whether it is Cerner or Epic or any of those. I have seen where ambient listening devices are in these offices that are automatically transcribing the conversation between a patient and the caregiver, and patient and the doctor, and then automatically uploading it as a starting point for the physicians to then update. So that is an area of growth for me that I could see. Again, I mean, these are just some examples that I can see now, but I'm sure there are a lot.
One more question and we'll, yes.
Thank you very much for a great talk. I just wanted to ask a very quick question, get your input on the generative AI, because you mentioned this is all the same thing, the name has changed. I want to just push back a little bit on that, because I think the AI 20 years ago and AI today, I think like what Dave played earlier today passed the Turing test.
Yeah.
I would say I was fooled. I thought it was actually his granddaughter. And are we ready for this generative AI or other names like you would call, especially in like healthcare and in in the business domain? Because I feel like something like Chat GPT, just the newest version of GPT 3.5 arrived. Got a lot of people by surprise. How do you see the industry, especially healthcare, reacting to it, and how long does it take until we actually leverage such technology?
I personally think there is a lot of potential for these large language models. Don't get me wrong, right? It's not the same as what it used to be just a couple of years ago, right? LLMs have come a long way, and their ability to comprehend language as a human has grown significantly. So I do see a lot of potential, but where I'm stopping short of saying is, I think there is still some work to be done in terms of applying it to specific applications in industries like healthcare or any. I think that's something that's TBD yet, right? Where I am seeing, World Economic Forum happened just a few weeks ago. I think I saw an article where every panel discussion had a topic about ChatGPT, right? Because these are CEOs and world leaders knowing ChatGPT. That is incredible, right? Talk about democratization of AI, it couldn't go any better than that, right? But now how do you translate that to real business value? And that is where I think people are like working on. From my side, I think where I see a lot of potential is this goes back to that diversity in your teams, is how do you set appropriate boundaries around how these models are actually built, right? This whole responsible AI practices become even more important as LLMs go much beyond what they are designed for. So for me, I think there is technical aspect of this that will continue to grow, where you have these foundation models getting verticalized for sector and for use cases. But equally important will be the non-technical side of it, is how do you design your AI processes in basically having a framework around it to make sure that you don't use it in formats that it was not intended to, right? And that is a whole area of ethics that is actually being worked on right now.
Great. Thank you. Thank you very much. So, to double microphone here, great industry grounding perspective. Now for the research perspective, which hopefully will be intertwined. Professor Lee.
All right, thank you for coming. So I have my own slides. So, all right. So I think I'm gonna give my goal here is to give sort of an overview of generative AI, and also give you some sense of like the technology, because this has been going on, and also ChatGPT has taken like the spotlight, but that's not the only one actually. And I just wanted to talk about a little bit of, and I'll talk about 3 different research that is about actually applying generative AI to problems in IS, marketing, and strategy, and so forth. So what is a generative AI? Let's just start with that. It's an algorithm that models data generating process, so you can generate things. Instead of the usual discriminative models that models the conditional probability of certain label given X, it models actual data generating process P of X, or joint distribution P, X, and Y, if the label is given, right? So, and also generative model can be turned into a discriminative. So here I just drew out generative AI, Google search term. So this starts from 2015, and we're literally at the exponential stage, as and I don't need to tell you that, but generative AI has been going on. The old models dates back to like really long time ago. You know, autoencoder things, for example, existed in like 1980s, and 2016 was like the invention of the generative adversarial net, which then started this craze up until now. You know, this, if you have time, just like, you know, some cool place to, fun place to visit. This X does not exist. They actually just collect random stuff, generated models that basically can generate X on the fly, and you have things like cats, you know, person. I think David just used that. One of the, this person does not exist. All right, so I'm gonna skip talking about, like, now I'll come back to ChatGPT. You know, like, I'm not gonna go into too much about it because everybody knows about it. All right, this I thought this was fun. Write a 3-line poem about being asked to write a 3-line poem. It's and then it just goes into 4th line. It does have some sort of, yeah. One thing I want to say about generative AI is still it is a statistical mimicry. It just memorizes lots of statistical structure of the natural language and is able to internalize that and then predict the next word, and has a semblance of intelligence. And it is one of many, albeit well engineered. No wonder, you know, people are talking about it. And its actually ancestor is a transformer model from 2017 from Google, right? And a lot of people, you know, the news is like talking about Google under attack. And come on, Google like originated a lot of this, right? Along with different, and there are many different language models that exist. I think a healthcare thing was asked. DeepMind also just released, not just, they have a language model called MedPalm, which basically now I think the performance is up to like 93% in agreement with like what physicians would say. And people can just ask random questions on it. Google is now launching Sparrow. I think it's expected to be launched in May or something. And they're focusing on new things like ability to cite, right, which ChatGPT lacks, and even heavier emphasis on bias and responsible outputs, as Jivan just mentioned, talked about it. And there are more, so it's evolving. All right, so if you've seen this already from my previous presentation, please do not spoil for other people. Can you guess which art is generated by AI? Well, I hear all of them. No, there's only one. Bottom right, I got bottom left. Top left, top right. Sorry. Bottom right. Well, okay, so it was the bottom left. And in fact, this one is created by Midjourney, went into Colorado art fair, and then it won the first prize. And then when later the judges were asked, like, what do you think about it? Judges were like, oh, this is cool. We don't care. You know, it's getting, you know, how about this? Now that you had to practice, what about this? Well, someone just keeps saying all of them. So. Top right, third one. It was a trick question. It is all of them. So if you want to try Stable Diffusion, Now they have a second version out. You can just type Stable Diffusion demo, and then you can just like prompt things and then just generate art on the fly. This one, if you just type Google in Google 100 top Stable Diffusion, you'll see some amazing artwork, right? And like DALL-E 2, text to image, Stable Diffusion. These are one thing that actually I think got attacked to oblivion, which I think is kind of unfair, is a large language model by Meta. They released something called Galactica a few months ago, and then people just like had a knee-jerk reaction, just like, oh, responsibility, it's forming stuff that's like wrong. Like, but come on, we have to start somewhere, right? What it is a large language model trained on scholarly article, right? Think about that. And you can ask questions, and then you can ask to cite things. They never mentioned it was going to be, groundbreaking and writing papers, right? You have to start somewhere. And I think this is something, it's so weird to see public have a different reaction, right? If a large company does it, they suddenly want to attack it. And OpenAI releases some ChatGPT without, some filters. Now everybody thinks it's it's changed the world. In fact, Microsoft and Google, and not Microsoft, Google, Facebook, all these big companies had this technology for a long time. And big companies, tech companies, were concerned with, making this responsible because of the compass, the Florida judge. Yeah, I'll skip on that. All right, so this is another text to video model. You can literally prompt and then create a video. Of course, the quality is not that good now, but it's only a matter of time, right? So this one is like horse drinking water. It just created this on the fly, right? And in generating art and music, AI is standing on the shoulders of humanity, right? And I created these in a few seconds, right? It's with the Stable Diffusion. It's just getting crazy. And it's amazing to see a perspective of artists, at least the ones that I talk to, artists and musicians, the content creators. There are a lot of positive opinions. And I thought they would, I didn't know how they would react. But the ones that I've been talking to, they're all positive because they see themselves as above the general public in their imagination and creativity. Right? They see these tools to get them even further up. So at a Meta conference for AI, I was sitting next to a dean of Juilliard who was really excited about the opportunities that these tools create and give to the musicians. Now they can focus on different types of creativity, maybe exploratory, transformative creativity. Judge of the art competition that I mentioned, they didn't really care. Content creators are very excited. But it remains to be seen, if this is actually true or not. I don't think we know yet. Here's a bit of a some milestone in the history of generative AI. The first basic autoencoders go as far as 1980s, and 2014, not 16, was the one of the first actual realistic instance generating model called GAN. After that, 2017, the Transformer, it's titled "Attention is All You Need." It's actually the one that started all. It's a grandmother of all of these language models, right? It stands for, and then the GPT stands for Generative Pre-trained Transformer. And most recently, the diffusion-based model has have been becoming really popular. So here's a bit about what they talk about in OpenAI and GPT-4. I searched for that. So first of all, Allen Institute says that humans have approximately 86 billion neurons in our brain, woven together by 100 trillion connections. So GPT-3 in 2020 cost $4.6 million to train, right? And this GPT-4, I don't think they have actually released the stats yet, and I don't think there's, no one knows unless you're in OpenAI. But according to one of the articles, and quote by Andrew Feldman, who is the CEO of Cerebras, is an AI supercomputing company. It could be 100 trillion. Who knows? I don't know. And that's literally about what they estimate the human connections to be, right, brain. And whether and this is the size of the parameters for GPT-3, and this will be the GPT-4. If that's true, but who knows? Now, the question lingers here. Will bigger models fundamentally change the game? No doubt it'll increase the performance, right? But we might need some new type of data to further advance the state of AI. I'm going to talk more about that later because it has already internalized a lot of the data that's available online. Not everything, but yeah. And one thing that keeps popping up, I think, we all know generative AI or AI in general is now GPT, right? GPT, a technology that that can affect the entire economy, things like electricity and steam engines. And in the last year, like 450 startups are working on only generative AI. So the scrambling for the next big piece of pie has begun. Now there is even a marketplace for prompts. People can sell their prompts for these language models or DALL-E or text-to-speech, text-to-image, text-to-video models. I'm going to skip this. So these are some mapping of what generative AIs are, they are able to do, what kind of application there are. It cross-cuts like text coding, images, speech, video, 3D, and so on and so forth. And what I'm really excited about, well, metaverse is not here yet, right? But if it gets popularized, you could imagine a text to a world model. I mean, metaverse is going to be generated by a generative model. And if you can think about, if you like Star Trek, we might not be far away from virtual reality holodeck, where you have like a text to world, right? I mean, we're not going to have a real holodeck because we don't have that molecular synthesizer, but text to a virtual reality world is a real possibility. Given this overview, I'm just going to talk about give a brief overview of 3 recent research from IS, marketing, and strategy. So the first thing is a paper that I worked with doctoral students Zhao-Chi Chang and Sunny Tambe at UPenn. You can see the paper here, tiny.cc/innovate. Basically here, our research question was the following: can AI represent innovation, and how is this even useful? And so we prototype using one of the generative model family, variational autoencoder, to estimate this entangled representation of patterns using both structured and unstructured data. Basically, we're finding representation of these multimodal objects like patterns and see if we can dissect them, so to speak. And ideally, we can dissect them and present them and embed them in an interpretable vector space and compare contrast. And because this is a generative model, we can actually synthesize new things, right? So, with this model, we can ask a bunch of applicational questions, and some of the spin-off papers are coming. With this, we can ask what happens if you combine patent A and B, automate lots of combinational creativity. How exceptional, you can ask how exceptional is a particular patent respect to some specific technological factors extracted by the AI algorithm. What innovation factors increase or decrease over time? Rank companies in technological factor X, and so on and so forth. Lots of applications. Here's a second paper I will briefly go over. This is by colleagues at MIT, Yale, and Northwestern. So they have this nice, neat paper titled Design and Evaluation of Product Aesthetics, a Human Hybrid Machine Approach. Their target is car design market, right? So car companies spend millions, lots of money for designing their product. And in fact, it's been shown that aesthetics are critical to automotive industry. And there are a lot of these cases. For example, huge market swings and significant costs are attributed to aesthetics of a car. Buick Enclave had like 30% over rendezvous. Beetles, 54% market share increase in 1 year because of the design success, right? And the other part, On the flip side, if your design is really bad, Pontiac Aztek resulted in 1.87 billion loss to GM primarily due to bad aesthetics. And so these authors, these scholars, they actually work with GM, I think. And what they're trying to augment is the design process. They're not automating this, and their whole point here is that it can augment this procedure. So this is a usual design concept, process, design concept process. They start with thousands of sketches and filter it down until they have only one or few of them. And after this, they go to do a focus group study, right? And then they decide on a design that is liked by most people. And they have to do this in different countries. And that's a lot of money. So what they proposed here is that they can get the market definition. This is the usual procedure. Market definition, get design concept generation, design concept testing, and then downstream firm stages. So these days, it's only all done by humans. Design aesthetics, and then you have a theme clinic, and then the focus group study to get the best ones. By the use of generative AI, they can automate augment a lot of these processes where generative model, based on what we've seen with the text to image and text to, anything, and they can augment this procedure. And again, they can also use machine learning model to get a sense of what people might, say about the aesthetics. Of course, this is not, it's not totally automatable yet. And lastly, how much time do I have? Okay. Lastly, I have another one by this Ryan Du, Asim Ansari, and Olivia Tubia. They have a paper called Letting Logos Speak, Leveraging Multi-View Representation Learning for Data-Driven Logo Design. So now you can do a lot of these designing process by internalizing things that matter. I'll talk about what here. So their framework here is that they can represent brand identity, right? By multiple different things. It's multimodal, meaning different types of data can enter in to basically define a brand identity. What represents a brand identity? You could have a logo, right? Logo is super important. Then you can also have a stated identity. What do they, their mission plans and their goals and company's goals and so on. Then also you have a consumer perception, like a brand personality. A lot of that can be scraped and understood from social media, for example, right? And you have a firm function like industry tags. Based on this, what they propose here, again, it's a generative model, but this time it's multimodal. It can incorporate a bunch of different types of data. And then they find an embedding of a company that represent all of these different characteristics. And now they can automate or augment a logo design or even identity website text design. So given data on one or more multiple views of the brand, find a representation that predicts across them. And and here you can do this, you can do these kind of fun things where you can ask, give me a Gucci of Nike, and then it gives you like the closest one is Under Armour, for example. Mercedes of Old Navy, it gives you like Ralph Lauren. Yeah. So given this, let me succinctly summarize the power of or capabilities of generative AI. The power here lies in the fact that it learns to generate any complex object. Any complex object can be literally like a firm, image, document, patents, jobs, or any digital twin of anything like consumers. If you have enough data, generative AI can represent that. Of course, it might be not totally right, but it can still do a good job given enough data. And in doing so, learns about the object and object space in detail and in scale, right? And then the trained model can then map up the object space, provide deeper insight that we might not have known before about that object space, augment the purposeful synthesis of a new and creative object, right? And do 1 and 2 at incredible scale and speed. That's the sort of the power of generative AI, right? what will be the landscape of large language models and generative AIs? So big tech companies, the competition will keep improving architecture and the model size. They're going to these firms with lots of computing power and data will be pre-training general knowledge such that later small companies like individual users like you and I could just use that and fine tune or modify some weights for a specific specialized task. And that's going to be the landscape. And of course, the competition for responsible model is full on right now. Harmless, citable, honest, certain human injected value. How do you control these large, very uncontrollable, somewhat very complex models? Right? A big caveat here I wanted to leave you with is that it's easy to mistake how AI will evolve and function by projecting views of human intelligence. It's definitely not like human intelligence, yet algorithm does not distinguish between quantum mechanics and children's story, right? If there is enough high quality training data, neural networks model will gobble it up and have a very good semblance of knowledge. It doesn't care if you feed quantum mechanics or just children's story, right? It doesn't know the difference. Well, to us, one is harder than the other. And just because it's hard for us to do something doesn't mean it's hard for the algorithm, right? Given enough high quality training data, that's the entire thing here, right? Whether it truly understands or not is a philosophical question dating back to like 60s. Since the 1956, the Dartmouth AI conference, they have been talking about this nonstop. And if you want to read more about it, there's a philosophy of artificial intelligence. It's more relevant than ever now. So for example, concepts like Chinese room argument and responses and definition of intention, consciousness, and so on and so forth. How is current generative AI lacking? I just wanted to talk a little bit about that. So Polanyi's paradox, named in honor of the British-Hungarian philosopher, is a theory that human knowledge of how the world functions and of our own capabilities are to a large extent beyond our explicit understanding, right? Termed tacit knowledge. So generative AI learns now only from the web or available data, like text, images, video, everything. However, it's severely lacking on data that we cannot really store, right? Like senses, like any taste senses. What is taste like, right? Taste, muscle memory, high resolution of things like feelings and emotions. Anything we cannot explicitly state or store due to Polanyi's paradox, the generative AI cannot learn, right? So when will this be overcome? Who knows, right? But once it's available for generative AI to gobble up, it's going to also encroach that. All right, so I'm going to end with some growing concerns, few examples. It can misrepresent facts and reality. We have seen ChatGPT just like BS through and then like say things like that's totally untrue, like it knows it, right? Produce bias and harmful content is another one. Also, power is in the hands of few. OpenAI, Microsoft, Meta, big, large companies, they're the ones who have the data and computing power to actually train these models, right? Who decides what data is used to train models? Because initial data and model choices have far-reaching consequences. It might lead into echo chamber and different equilibrium. And also, who owns the rights to these data, right? I think a bunch of artists are suing a bunch of these companies for copyright issues and intellectual property rights. How do we protect potential extraction of sensitive data that might be, coming up? Generative AI is so powerful that it will change market equilibrium for many industries, right? And that's something that we need to be aware of and study. And anyone with the computer can now launch a massive scale, believable bot attack and misinformation. It's really easy now. Anyone in their basement can do this. So this is a big concern. And that's all I have.
Thank you very much, DK. That was fantastic. Wow. I think in the interest of time, we'll keep going with our presentations, and we'll have plenty of time as a reference to have robust Q&A in our panel discussion for over an hour at the end of this. So with that,
Gordon Birch. Thanks, Pete. And thanks to the other speakers. Jivan, you teed this up quite well. What I'm going to be talking about here is really focused on AI that's deployed for consumer interaction. And a lot of this is very much focused on conversational AI, for the simple reason that a lot of the applications there are to, in fact, interact with consumers. And many of us have probably all interacted with conversational AI now if you've tried ChatGPT. And so part of what I'm going to touch on here is related to issues of user interface design, but also related to issues of like ethics and privacy and data sharing, because I have to ask the question, when any of you interacted with ChatGPT, did you think about the fact, why is this free? Why do they deploy this thing just so everybody can use it when this is a company that's probably trying to make money? If you think about it, the reason is because you're giving them data, right? They got so much data in just a few days, which is totally massively going to improve their model. They can make way more money off of it, right? And nobody even thought about it. So these kind of considerations are pretty important to think about, as is generally questions of trust in these systems, which Jivan again teed up at the beginning as a point of issue. So I'm going to talk about two specific studies that I and co-authors have done in the last year to year and a half, 2 years, I guess, that we're continuing to do, which are all in the area of conversational AI. And thinking about specifically the social design of these things, because they are in effect social entities, right? You deploy these and they will have social interactions with people. And a lot of the focus has been on, as you know, we've seen a lot of discussion today, technical implementation, like how does it act? How do we drop this thing out there and get it working and performing well without as much thought necessarily to, well, when will people trust these things versus not? Or how will they interact with them? Or what consequences may deploying the wrong thing have on a consumer's behavior or some other user's behavior? Because these things are actually collaborative in many settings, right? The process is not just the machine and just the person, it's the joint interaction between the two. You want that to look good. And you have a little bit less control over what the user is doing than you do over the system. So you need to think about it, okay? So focusing on conversational AI, I think, you know, if you go back a few years, most of this was text-based, like chatbots and things, but the vast majority do not work particularly well. Like I think Meta has put out statistics basically indicating that more than 70% of the chatbots deployed on its platform by businesses are basically non-functional. So if you test them at random, they make mistakes within like 3 points of exchange and they get lost and need human intervention. They probably improved a bit now in the last couple of years. But a lot of businesses are deploying these, not just on third-party platforms like Facebook, but also internally for their own system. There's a big thing in the banking industry, for example, where you have Erica from Bank of America. And also increasingly, as Jivan mentioned, now we're starting to see a shift towards voice-based chatbots and conversational AI using voice. BP, for example, using this for internal SLA agreements with contractors and things to interact with their quality issues when they call in. So there's lots of examples I could point to, and I can give you stats like conversational AI market is supposed to be over $18 billion US in the next 4 or 5 years. It's a big thing. I don't think I need to make that point necessarily. The context is important, okay? And when you think about issues with sort of the social design of these tools, especially ones targeted for consumer interaction, well, there's a lot of questions that pop up, like what should we be doing? So after I have the system in place and I throw this thing out there, there's a lot of choices I can make that are sort of aesthetic in nature or social in nature. Like, should I give it a name? Like Erica has a name. Was that a good idea? I actually have no idea. And neither does Bank of America, because they probably never ran an A/B test, to be frank. And actually an interesting thing here to think about is this is just another computer system, right? Which is being deployed for a consumer interaction. And there is no reason you cannot be A/B testing the deployment and design of these things, right? So you could A/B test, like what name should we give the thing? If we're going to inject some personality into this bot, which one should we give it? Maybe we can personalize these things, right? So actually that's an important thing to have in the back of your mind, that you can always be designing to improve these systems, and maintaining this sort of experimental mindset can be a good idea here too, just like you would do with like ad copy and things like that, right? Anything consumer interaction based. So several years ago, you may have seen this or recall this, when Google was introducing its AI assistant that could make calls on your behalf and to make a booking for you at a restaurant. They demoed the thing and it was like amazingly high quality, right? To the point where you're listening to it call, I think it was a hairdresser, on behalf of a user to make a booking and actually having a conversation with the hairdresser that answered the phone. And the woman clearly had no idea what was going on because the bot was injecting ums and ahs into its speech patterns. It had affected a Pennsylvania accent, and the woman had no clue. And it hung up. And everybody in the moment was like cheering and like, wow, that's so amazing. But then you had this flurry of really negative articles with all these people who were super freaked out by it. Basically, like, this seems deceitful. How do I know it's not being personalized to manipulate my response and what I do? And it's led to legislation, actually. So like in California, there's the Bolstering Online Transparency Act, where you now legally are required as a firm to disclose that this thing is AI at the beginning of an interaction with a consumer. You can't keep that from them, right? Because there's this big sentiment, this negative reaction people have had to this idea that it's so good that I can't actually tell because it passes the Turing test or whatever, right? Amazon had a really creepy example quite recently where they were demonstrating the use of generative AI models for voice cloning that you could use on their speaker service. And they gave an example using a kid's dead grandmother, and it didn't really go over that well. I guess I didn't think it through too much, right? So anyway, the point is this is important to keep in mind, okay? So what we're looking at are a few different aspects of how a consumer in particular may interact and interface with these tools, how they may change their response depending on if they are aware that they're talking to AI versus not. And I know it may seem like you'll figure it out. And that's generally often going to be true. You can kind of parse out from the conversation that this is not a person pretty fast, but there can be a difference between upfront disclosure right away and the person kind of figuring it out after a couple points of exchange and feeling deceived, right? Which may not put them off on the right foot in the interaction, okay? A lot of these things are tied generally to this idea of like, do they trust the other entity? That's really what we're thinking about, is like a latent thing that we're focused on. And we're gonna look at a few things. So we're gonna look at a first context where we ran a study where we looked at in sort of imbuing a text-based chatbot with sort of social affect, right? So we're imbuing it with a name and social presence and other cues that I'll explain in a minute that kind of signify more of like an anthropomorphic agent, so a human-like agent on the other end. And what that did in this transaction context, not only to consumers' willingness to complete a transaction, but also to price sensitivity. So we saw that that moved, that they became a bit more sort of thoughtful about the prices they were being offered, as well as their willingness to share data with the thing, right? Because consumers are privacy concerned potentially, and these things can manipulate privacy perceptions and privacy concerns. And data sharing, as I mentioned at the outset, is a big deal. Like, getting data is really valuable to companies, but regulators are worried about people sharing these things at inappropriate times too. The second study is looking at voice-based conversational AI as the context. And here, the first one was a field experiment we ran in partnership with a company, a retailer in the US. The second one is actually a controlled setting because we're in an actively trying to identify a partner to run field experiments with. And I'll talk at the end a bit about this because voice-based conversational agents have a lot of applications beyond just consumer interaction. Like, you can think about using them for political polling, where the implication could be that you actually change the answers people are willing to say, like how truthful are they in their responses on sensitive topics and things like that. So we've been talking a little bit to a partner about doing some experiments with that. Okay, so I'll give a bit more detail on each of these. So our first experiment, because we wanted to understand things like how, whether trust impacts of various social features that are incorporated into a bot that a consumer interacts with might have effects on things like price sensitivity. We identified a retail partner that would basically, the way they had done their sales process in the past, or actually it was a purchase process. This is like a used clothing buyback retailer. So they basically, all their inventory is sourced from people who already have clothes. They buy them from them and then resell them. Okay. They used to do all of this in a really manual fashion. So as Jivan mentioned at the outset, a big motivator for adopting these things was automation and speeding up processes and making things more efficient. That's what the company was really worried about. So it used to be highly automated, or sorry, highly manual, where somebody would kind of go to the website, or they'd go through an advertisement on one of many different platforms, soliciting their inventory, their clothing, and asking, can we buy these things from you if you have these brands? And the process would basically be fill out a web form, submit, an employee gets back to you, there is some exchange either over the phone or via email, there's some negotiation that happens, and then eventually when a sale happens, basically they produce a shipping label for you, you print it out, you send it to them. So they initially engaged with us to automate this whole process using a conversational agent to take care of most of it, right? So we use Google Dialogflow. We deploy the chatbot after it's developed onto their Facebook business page. And then consumers are pushed through ads to the chatbot, which then identifies what clothes they have, solicits photos from them, figures out the labels and the number of units, and then generates a price offer for the person. If they accept it, then it automatically sort of produces a shipping label for them in the moment after verifying their details, and then the person ships it. And it kind of cuts down on transaction time, like order of magnitude, right? We do this work on behalf of the company, and in exchange, they let us do other experiments on top of the thing we just built for them. Okay, so we run some A/B tests, basically incorporating different social features. So we develop 8 different chatbots, which have slightly different characteristics, and then we're randomly assigning visitors to a different chatbot, and we see which one has what effects on the outcomes that happen. So what are some of the social features that we experimented with? So again, the idea was at no point in this experiment do I believe anybody thought they were talking to a human beyond the first 2 or 3 exchanges. Because if I was to show you the conversational dynamic, it's basically like you get drop-down lists that pop up and things like this as part of the conversation. So they know. But we do anthropomorphize these things, right? Anthropomorphize these things in different ways. So for example, we will have message typing bubbles showing up while the chatbot is producing a message, or we will provide read receipts. When you send a message to this thing, it kind of has the double check mark that says this thing's been seen, this thing's been read. These are sort of social cues that people use in regular conversations on chat with other humans, right? We also incorporate typing delays. So a chatbot could respond instantaneously, but we purposefully time the response such that it would be, the equivalent of 70 word per minute typing speed, which is a little above average human. Okay. We also incorporate a name, things like this, right? And so what we do is we randomly incorporate in different chatbots, different combinations of these features. And then there's a control, which is we don't do any of these things. We just have instantaneous reply, no read receipts, nothing. It's very sort of robotic interaction. And then we examine what does this do? Oh, and I didn't mention the other thing that we are randomizing at the same time when we get the price offer that we're going to send to a consumer for the clothes they have to sell. We're going to randomly perturb the offer as well. So we're going to randomly make it a little bit higher or a little bit lower per unit. The idea being now, regardless of what you brought to sell to the company clothing wise, we're going to randomly bump up your offer and see, are you systematically more willing to take a lower offer if we do the right thing? And we show that actually we can make that happen just with these social characteristics, to my earlier point, right? You can imagine opportunities for consumer manipulation, et cetera, right? Depending on how you think about these things, whether this is good or bad, probably depends on what stakeholder you are. So what do we see? As we incorporate more of these like anthropomorphic characteristics into the chatbot, we can kind of bump your probability of completing a transaction by 10% on average, which is quite high, right? And then also, if we have enough of these treatments in place, your price sensitivity starts to go up. So you become systematically more responsive to changes in the price offer that we're giving you, right? So it's kind of interesting. On the one hand, we're making you more human-like. You become more likely to complete the process altogether. But at the same time, you're much more sensitive to the price offer that you get. So it's like, I trust you more, but at the same time, because I know you're a bot, I'm also second guessing your intentions and what you're doing with prices a little bit more, right? Depends how you think about this. So there's kind of parallel effects that are happening that need to be thought about. These are very important points of consideration for like a retailer, right? Because some of their number one concerns are like process efficiency, good responsive consumer interaction, the whole reason we deploy a chatbot, but we also care a ton about price sensitivity and pricing decisions, okay? This on the left is showing where the effects happening process-wise in terms of when we ask you to share data with us that we need to complete the transaction, where are the effects actually showing up in that data sharing? And we don't see, if you tell us what size box you think you need, no, the treatments aren't making much of a difference there. If we ask you for your mailing address, then we start to see some weak effects once we get to enough characteristics baked into this thing, human characteristics. And then it starts to really have an effect when we start asking you, what is your full legal name? What is your phone number? That's where the effects are actually coming out. So it's like the more sensitive data is where things are starting to happen when we give these enough features in place, right, on the chatbot, which is, again, a little potentially scary to think about. Okay, so this is study 1. Well, now I'll briefly talk about a second study, and this is one that we've finished. This one's not yet published. It's sort of in the peer review process right now. So what we do, this is a controlled experiment. And the setting's a little odd to think about, but basically what we're doing is we're having a bunch of human subjects who connect in online. So they're recruited through prolific.co, which is an online platform for research subjects. And these people are recruited to play a game that many of them will be familiar with from participating in these kind of experiments, which is a trust game. It's called the investment game. Basically on the right, this is how the game works in the traditional setting. So a participant comes, they're paired with a random other partner. They are then asked, would you like to play with this other person? And they can choose to walk away and keep some amount of money they were initially allocated, or they can choose to play with that other person and sort of hand the money over. And then it's up to the other person to decide if they just keep the money and leave, basically take it from them, or instead kind of roll some dice. And if the right numbers come up, everybody gets more money and they give some of it back. So it's a trust game. The whole point of this is to understand when will people trust other people. We take a variant of this game where we replace party B with an autonomous agent, right? So voice-based. Person doesn't know that necessarily. That's one of our treatments where we disclose this information to them that the other party is AI. When we don't disclose it, there's no indication to them that this is not a person that they're playing with. And there's a variant of this game which allows a little bit of communication to happen between the two parties. Okay? So we basically take that variant and we put it online, and the communication can happen either through a text-based message we send to you, or you get an audio message, and the audio message is synthesized. What do we use to synthesize? Well, we have some code. So Baidu had a model from like 2018, which I'm sure is like latest stuff is a million times better than this, but we're going to show even this works. Okay. And we synthesize messages from the original study that was published that people actually passed in the real experiment. We synthesize voice messages. So they're like things like people promising that they will, you know, roll and give some money back if the first party just agrees to hand over the funds, things like this. Okay. We synthesize using multiple different voices. So one is just a randomly selected voice. We have a corpus of like 1,000 different voices. We could use this process to figure out an optimal voice for a particular customer, for example, right? You think about that. We have another where actually the way we have people read the consent statement to participate in our study, we make them call into a phone number and read it to us. And it's a, I don't know, 5 to 7 second audio clip of them reading a fixed set of text, which was purposefully designed to hit the right phonemes, et cetera, so that we could synthesize off their voice after in a way that would sound okay. And we do this as another condition where some people are randomly assigned to basically play with themselves, and they don't know that. Now, the important thing to point out about voice, unlike a picture, like if you showed me a picture of me, I would recognize it immediately. You don't actually recognize your own voice immediately when you hear it if you're not primed to be looking for it. Because the way you hear yourself, you resonates through your skull, your own voice. And so when it comes back to your ear, it sounds different than how other people hear it. This is notable, right? You may have experienced this if you hear yourself on a recording and you think you sound weird, right? That's the basic idea, because it's not how you hear yourself. So if you're not listening for it, you don't know you're talking to yourself. Now, the fidelity of this is probably not a perfect copy of your voice, but it's systematically closer than a random voice. And so we can kind of test this idea. If I personalize the voice, the aesthetics on this thing to be like you, a lot of literature in psychology that basically shows people like other people more when they look like them, or if they're from the same place, right? We want to see, like, to what extent is that going to influence trust in this setting and make people likely to like risk money with another party? Okay, so we go through this whole process. There's a bunch of infrastructure on the back end to set all of this up and do it on the fly. The voice cloning happens in real time. Okay. And what do we basically show? Well, the most interesting piece here that I'm focused on is if we give you a clone of your own voice versus a randomly selected voice, the conversational piece, that's where I'm going to focus here. It gives you so 70% of people basically agree to play with the other party in the condition where it's using a random voice. And that number bumps up by about 10% in relative terms, or 7 percentage points when we give them a clone of their own voice. So people are more likely to hand money over if the message they get sounds like them. In particular, this is also really dependent on the fidelity of the audio. And the reason I'm bringing this up is that the quality is only getting better as time goes on. So these effects are going to get larger as time goes on. Okay. Why is this a point of concern? Well, you know, basically we frame this paper as a dark pattern type thing. Like, you may be worried about the fact that this is not that hard to do, and it can shift people's willingness to participate, share data, give money, etc. And so the question is, how should we be thinking about regulating this? What's okay? These people never technically gave permission for us to clone their voice, right? Actually, we deleted the data afterwards because IRB wouldn't let us keep it. But right? So like question is like, how do we maintain responsibility in deploying these things? What should the regulations look like? There's nothing really there yet. Like the FTC only convened panels on these things within the last year or two, and they didn't really figure out what they want to do. It's not clear how to manage it. Like, is your voice your data? Kind of goes to this idea of IP and other things that DK mentioned with the generative models that are all trained on everybody else's text and code, et cetera, without necessarily getting permission to do those things. Okay. So as I mentioned, there is legislation that's been coming out around these things. It's not clear whether that legislation will totally address the problems well. Kind of need more work on that to understand whether just simply disclosing is enough. In our setting, we actually show that even if disclosure is present, the effects still kind of happen. So it's not purely about people not knowing it's an AI. It's sort of like subliminal things kick in, I guess, where it's sort of like, I'm just more trusting of something that sounds like me, like that does something psychologically. There are recent instances where people have used voice cloning for quite nefarious purposes to, social engineering, et cetera, to get money basically out of a bank successfully. And there's fairly recent work as well that has talked about sort of privacy aspects of a voice signature from a consumer, that you can actually, using a voice, predict facial features of the individual who owns that voice fairly accurately. And then that raises the question, well, I can know things about you sort of demographically quite easily just based on how you sound, and I may do things with that information. If you think about some stuff that we're looking at doing now with audio advertisements, what we're basically doing is we're going to run a bunch of audio ads on Spotify. And some of these, we're not getting into the space of interactive audio ads, by the way. So conversational AI in the middle of like a podcast. So you can ask a question, it'll just start answering you. Like that's not that far away. But one thing we're looking at now is, well, if I know I can target my ad to a zip code or something, and I know the demographics of people that live in that zip code, and I have a bunch of voices that I've gotten from people because I paid them to read some stuff to me, I can take like an average voice embedding from that zip code, and I'm going to dynamically give you the voice over in the ad that's the one that's probably most likely to be like you, and then see what does that do to my ad performance. Okay, so that's something we're doing right now. And then the other thing that I mentioned is thinking about using these tools within political polling, because there's some recent work that Pew ran experiments where they basically showed the mode by which we collect data on political questions shifts people's answers. Like if you fill out on a web form versus somebody calls you and talks to you, what's your willingness to admit that you would vote for a particular person or party? That can shift around. You can imagine this stuff can also affect people's willingness to be truthful in what they say. So we're kind of this sort of directions we're taking these things next. Okay, so I'm going to stop there. Thank you for listening.
Fantastic. Okay, we're almost there. One more with Avi.
Okay, good afternoon. Microphone on? Can you hear me? Okay. Well, thank you for staying. I'm the last thing between you and the coffee break, okay? So I try not to overdo it. I'm humbled by all the previous presentation. There's a lot going on. And you haven't seen even the beginning of the play. I'll give you my own experience. When I was doing my PhD in Texas in the late 70s, Fred Busey was the legendary president of Texas Instruments, called us, the high-end engineering students. Each one of us got a PC. It was a 990 PC with graphics and mouse and everything, or something like a mouse. And he says, find me an application. I have a technology. I don't know what to do with it. I don't know how to sell it. So I had this game, I forgot its name, with the two plates running around and the ball kicking around. And I'd run in my basement. I called all my colleagues. We spent the whole evening. And we had an idea. Women should put cooking recipes on it, okay? Which still today nobody does, okay? But we could never figure out spell check, grammar check, Excel, email, and all what you saw today. The point is, it's extremely difficult for us to see through technology. On Friday, we had the faculty meeting with about over 100 faculty, and we spent more than an hour discussing how is ChatGPT going to change the way we teach our MBA, PhD, and undergraduate students. Frankly, no one knows. People threw some ideas, but what frightens everybody, the ChatGPT, which is still basic, passed the USMLE, which is the medical licensing exam, with an okay grade. He did the final exam in operations management at Wharton School. It passed it with the BOB+. So everybody's scared now. How should I teach? All these homework assignments, write a reflection on, gone down the drain. Do something else. And how do you design questions? And more importantly for me is not the cheating, is how do I use it to personalize teaching? How do I help students with difficulty studying and I get them up to speed? Because these are crutches. When I started learning mathematics, we did long division. We multiplied with the logarithmic table and slide rule. So we can do a lot more with the technology, but we don't really know how to do it, which is very important. And the other thing, remember, there's a big philosophical discussion. Is mathematics an innovation or is it a discovery? And a lot of smart people still discuss it. Same thing about AI. Is it an innovation? Is it a discovery? And if so, what else are we going to discover there? I'm going to talk primarily about healthcare. Healthcare is very interesting because without healthcare, we are nothing. We're dead. So we need to stay healthy to produce. Economically, it's the most inelastic field of our expenditure. You spend all the money in the world you have to stay alive of your loved ones. And I just got a report a few days ago from Anderson Horowitz, and they predict that the largest company in terms of valuation next few years is going to be a healthcare company. Maybe United teams up with Visa, who knows what, there's some speculation there, but clearly a lot of money is going to healthcare. We're now already 20% of GDP. It's a lot more than all the advertising budget of the whole world. So Google, Amazon, Apple, they're all looking, how do I get in there and how do I bring in technology? So I want to talk about some of the interesting issues that are affecting the roadblocks. Because we can talk about technology in isolation, but really how do we bring it into practice? So some observation of medicine, okay? Ask ourselves, what is a physician doing? Because physicians are still the core of medical care. So they look at interpersonal assessment. They look how you walk into the office. It's called the gait, your skin color, your mental state. Are you washed? Are you clean cut? You look like somebody who lives on the street or somebody who lives in Brighton, Massachusetts, okay? They do physical exam at times. They look at scans, X-ray, CT. They look at text reports, referral notes. Somebody send you to me as a psychologist, orthopedic surgeon. Why are you coming here to see me? Okay. I look at the flow report. What happened to you on bed overnight when I come to the morning rounds to treat you as a patient? Okay. Then there's tabular data, the lab report, the CBC, the complete blood count, medication, etc. There's time series. What is your oxygen saturation? Is it going above or below over time? Your blood pressure, EKG, EEG, the brain function, fever, urination, what have you. The point is, can a machine use multimodality data to collect all this? As we speak today, it's close to impossible. So we take one channel, we just look at EKG, we apply AI to it. We look at blood pressure time series, we apply AI. That's not how physicians work. So we need to combine multimodality. You see, it's just some example, and that's difficult. IBM paid a lot of price in trying to read physician handwriting. It fell on its face. It's impossible. And physicians don't like to type. So we're developing technology, voice to type, etc. The point is, it's extremely difficult field. This is how our healthcare system looks like, okay? Now try to fix it, okay, without breaking too many parts in the process. And over the year, it becomes even more complicated. Now, if you look at the CMS, which kind of funds a lot of our care, they fight between progress, challenges, and opportunities, and there are different areas there. But I would like to look at the general elements on there. There's a big research effort. We are working with people at MIT looking at how to combine all these data modalities together. It's a very long-run process, okay? And some of you may not be alive by the time we crack this nut. It's extremely difficult. So we try different shortcuts to try and understand the data, digitize it, normalize it, and use it for machine learning. So I'll focus primarily on some results we have in an ongoing research with two of my colleagues here in campus, Mohammed and Vijay, and trying to understand basically why things are not moving as fast as we want. Part of the issue is lack of human touch. When you go and talk with physicians, they assess how smart you are, how sensitive you are, how desperate you are. And they tailor the message accordingly, the positioning. The pathology looks bad, but you have a choice. Or you know what, there's nothing we can do. Where do you define the line? Do I get a hug before I leave the room? Do you look as if I'm lost case? Or you say, I'm going to refer to the #1 national expert, and they will help you stay alive or alleviate your pains or whatever. So these things are extremely difficult as we speak today to automate, okay? Collecting, sensing the patient reaction is one of the challenges we have now. How do you get feedback from body language, from the tone of conversation, the eye movements, the positioning of the caregiver who come with the patient? So that's something we're still struggling with. The other one is the responsibility issue. What do I mean by that? Diagnostic error is the reason physicians are paying for medical insurance. If you're a gynecologist practicing in Massachusetts and you deliver a baby, your insurance premium is around $160,000 a year. It's a big chunk of your payroll. But what happens when AI makes mistake? Who is going to insure an AI? How much premium are we going to pay? So there are questions there if there are any mistakes being made, and algorithms do make mistakes, okay? The vendor is responsible, the physician is responsible, who takes responsibility, and who's going to pay for the errors? The insurance company may say, we're not covering AI mistakes. We don't know how to price it. We don't know how to put it in order, okay? So there are different frameworks that the FDA and the SAMD trying to do, but it's still a challenge that we're struggling with. Another issue that we see a lot, and we are working with different companies in this field of AI and medicine, is the issue of reimbursement. It is one thing to come with an invention. It's another thing to convince somebody to write a check to pay for the product, as fancy, as cool as it is. We all like ChatGPT. One of the main reasons we like it, it's free. If I have to start paying money, I wonder what will happen. If I have to pay $5 a minute, usage will be different, okay? And now they're going to charge, I think, like $40, $50 a month starting soon, okay? Because every query is expensive. Now, reimbursement is an issue because in medicine, the model is very simple. I buy, you're selling as physician, and she's paying as insurance. But she doesn't want to pay for everything because she has to pay her executives, okay? So how are we going to implement it, okay? In Germany, in the UK, there are certain rules that forces the third-party payer to pay for prescription apps. So you can use different applications for mental health, for cognition, meditation, or diagnosing skin lesions, and they pay for it. In the US, we still do not have it. There's one which they approved, and it's hardly moving. So the National Health Services say there are 5 criteria: clinical benefit, clinical added value, intended role, indication, and usage, okay? And they go about it in the UK with the NHS, trying to pay for it. In the US, it's a little bit more convoluted. We have the FDA. But the FDA focuses primarily on how safe it is, but not on the value added. So the fact that you got FDA approval does not mean that anybody is going to pay for it, okay? That's another challenge that we face as we bring this technology in. As far as barriers, okay? FDA, they can give you the okay, but then the CMS, which pays for it, may say it's too expensive. We just had an Alzheimer medication issue where the FDA approved it, and the CMS say it's way too expensive, that the benefit is too small, we're not paying for it. You want to pay for yourself $50,000 a year to slow down your dementia, go ahead. We're not paying for it, okay? There's no policy in the US around it, and Medicare focuses on the elderly. So it's not enough that you come with a good AI product. Will it help people over 65? And when you combine Medicaid, each state has its own ruling. They say, okay, it may be good for the people in Massachusetts, but New Hampshire say, we don't really care, or we're still not convinced the medical impact is worth the money that your AI product is delivering. The private payers are even more complicated because they say, if you bring in AI, fine. It makes you live longer, fine. Will it cut my insurance premium? If I don't see economic benefits, you can keep it in your box. I don't want you to bring it because I'm not going to pay for it. So second opinion, okay? Will second opinion cost me more cost or less cost, okay? And the question is, if you bring me an AI that slows me down, radiology is a good example. The first AI interpretation model came around 20 years ago. Still, they're not used today in practice. Physicians don't like it because if I see a lesion, I say, go do a biopsy. If AI say, I see a lesion, say, maybe it's a false positive, maybe it's a false negative. Now, if I ignore it and I read 1,000 studies a year, once every 2 or 3 years, I'm going to miss a lesion. I go to court and the jury will always convince me and I have to pay premium and pay more for insurance. Because they show here's the man, he lost his wife, you missed on the mammography. But if I want to be safe, I send every patient to biopsies. Cannot do it. So the fact that now I have to argue and overrule the AI puts me in a risk I'm unwilling to take. And it slows me down. And I'm paid per study. So if it takes more time, look at my report, look at the AI report, I'm getting the same amount of payment. But it slows me down. Thank you very much. Put it on the back shelf, okay? So it increases my liability. It complicates my process. How do I bill for AI advice? Who is going to pay? I need codes for that. So it's still having a hard time taking off the ground, okay? While we think it's a lot of value. Then how you demonstrate the real value. One of the things that you should remember is clinicians do many things. They don't just do one thing. They do diagnosis, they can send you referral, they can consult you, what should you do next? Don't worry about it, or come in next 6 months, or maybe you should take more blood work, or go from CT to a PET CT. So they have to optimize on many parameters, okay? But most of what AI does today is fairly narrow. They can read the blood work, they can read the EKG, and so on. They give you a point solution. It's not what physicians do, and it slows me down. I have to look at this machinery, turn it on, and I'm not sure how good it is. So the other problem that we deal with is improved accuracy. Look at pathology, digital pathology. Everybody who knows image processing, try to get the pathologists out of business. So you bring it to the hospital, and you say, this will give you better accuracy. Hospital says, I'm not getting more money for it. Keep it for yourself. Because the third-party insurance company is not incentivized to pay for better accuracy of image processing of digital images. So how we get out of it? It's a dilemma we all deal with now. Because, yeah, if it makes me more productive, maybe. But accuracy, still nobody pays for it. That's the way we are now. Is it humane or not? It's a different question, but that's the state of the art. There's undue societal pressure. Some of you talked about it earlier in the 2 presentations. I won't repeat everything, but just give you one example. Society has unrealistic expectations from technology. Remember, everybody was talking about the driverless car? We still don't see it. And I drive a high-end Audi. When it starts snowing or raining, all I hear is alarms, okay? The car goes crazy. And I have no technical way to go to the 15 sensors. I don't know where hidden in the car to clean them up from the ice. So if you try Palo Alto, which is flat, everybody moves slowly, with traffic jams, I'm sure it works okay. In the Northeast, where we live, it's going to be many years because the white lanes are covered by snow, okay? With a little snow, it doesn't know where the edge of the road is, etc., etc. Not to mention, when I go to Canada, the speed limit is not 55, it's 100, so the car goes crazy, okay? Because it reads kilometers instead of miles, okay? So there's a way to go. Now, the other problem is society, and God talked about it earlier. When AI makes mistake, we start a crusade against AI. Physicians do make mistakes all the time, but we accept it's human. When AI makes mistakes, say we should stop using AI, put a moratorium, take it all out, and rethink everything. So society has very little tolerance for AI mistakes, okay? And every single mistake, society will say, well, we're not going to use AI until we redo it, like put all the Boeing 737 MAX on the runway for 2 years. And that puts a huge risk on the developers. Because we put all the money now for 2 years, we don't get cash flow, we have to shut down our R&D activities. There are a lot of worries about bias and discrimination. Here I have to be very careful, but this is a very sensitive topic, but we need to address it face on. The talk is cheap, but AI knows only what you trained it on. So we say, oh, it's biased data. So let me be realistic. If you talk with the obstetrician, they have charts on baby growth in the womb before they get delivered. Those charts were based on white women in Ohio in the 50s. And everybody uses it. And nobody says gynecologists have bias, they discriminate. That's what they do. It's a quiet secret. Because I do research on the field, I was shocked myself. Our population now is far more diverse than white women in Ohio in the 50s. Our size is different. We're bigger, we're taller, but that's what they use. So there's some effort to change the scale. The point is, our expectations from AI are way higher and exaggerated as compared with what we expect from physicians. Most medications are being tested on men between 30s and 50. Now we bring some women. There's very little medication test on people over 70 years old, which is those who consume it most. There's hardly any study on drug interaction. If you go to pharmacy and say, what happens if I give a patient these 5 drugs? People get things for cholesterol, blood pressure, depression, I don't know, restless legs, or God knows what. Nobody knows. It's a lottery. It may kill you, it may cure. Nobody tested it. So again, we have expectations, what I call artificial barriers, or some idealized version of the world. Besides, if I'm treating people in another continent, in another race, even if I do a whole study in the US, it may not be relevant for them. The size is different, the different food, different allergy, who knows what, different gene composition. So we have a lot of unrealistic expectation with a high ethical bar, which slows down innovation. Another issue, and we do some research on it, is interpretability and trust. To adapt AI, you need to trust it. That's the mediators that everybody talks about. And the point is, interpretability is built as the mediator. But the black box are kind of accepted. So people like Rudin and others say we need to have something that is interpretable, like a decision tree. So I see where the results come from. Okay, you can see it. The problem is, if you read verdict by judges, they're highly uninterpretable. The same case go to different judges, you get different verdict, different jail time, etc. But again, we expect machine to be way more consistent than human being. Okay. Now, recent study done by a PhD student of ours and a colleague of mine, we look at decision making under uncertainty. So a decision that you make is ex ante the right one, but ex post turn out to be producing the wrong result. You give the right medication to patient, but they die. It happens at all physicians all the time because you missed something or the patient has unexpected negative reaction. You do a stock market analysis, you buy the right portfolio of stock or the right stocks, and then you start losing money months in advance. So you made the right decision, but the uncertainty runs against you. Long run, it might be the right policy. But short run, you get negative outcomes. So we look at that, and what we find is trust is not necessarily a perfect mediator for AI adoption. As uncertainty increases, I use more AI and I trust it less. Because I don't know how to judge the performance of AI, because I can get the right decision, but ex post, it looks bad. So how do I judge it? Okay? And interpretability may negatively affect AI. If I provide good interpretability, the user will say, I can do it myself, shut down the AI. I see the logic, I can do it myself. Okay? So things that seem intuitive, when you go to the world of the business context, you make investments, you treat patient, you guide the individual, which is frequently making decisions under uncertainty, the old rule don't seem to apply, and we need to rethink this context altogether. Beyond that, the management issue with AI are very complicated. Most AI systems are limited to point solution. I read pathology, I read the face, I write you text with chat, etc., okay? But this does not get an impact in the business world. The best example was your first example, processing the insurance claims, where the AI was a point solution, but basically had an impact because it was an end-to-end solution for the Veteran Administration, okay? It was not like we read document and we understand. That's what I call a point solution. The impact, diagnostic radiology, digital pathology, protein folding, drug interaction, these are point solutions. And the business impact, while it's cool from AI perspective, the business impact is very limited. You can look at, and they're hard to sell, of course. If you look at radiologists, that's a good example. You can find it on the internet. This is what a radiologist has to do. These are 30 tasks. I can automate one of it, which is here, perform or interpret outcome of diagnostic imaging procedures. Hey, what about the rest? If I pay for doing the rest, why do you care about this automation? Maybe I can get like 10% more productivity, but I need them for everything, so I keep them. So it does not really move the dial in any significant way, okay? So application solution, still the workflow change a little bit, like I do triage in ER. The software, okay, can show me how to do a triage fairly quickly, okay? That may help. Determining task priorities, what should we do first? Detecting which clinical task, should I send the patient to an imaging study, to a physical exam, etc., okay? So this can help. But really the impact comes with what we call system solution. When AI can change the whole workflow and produce a systematic change in the business process. I change a hospital and so on. To me, it's answering this question. How would the hospital look like if we were to design it from scratch, given what we know now about medical AI? If you have a blank sheet and you build now the hospital of the future, not taking an old building from the 19th century and adding rooms, but building it from a clean slate, how would you design a hospital today, given what we know and what we expect to know about AI? To me, that's the test that we should be using. Now, what you see in here is drug companies are already in here. You see a lot of it here in Massachusetts are using AI. My son runs one of what he claims is highest valuation medical startup here in Boston. And when ChatGPT came out, he signed up for the API version, and he have a team that are working on programming some controls into some medical procedures they're doing. Okay, they deal with complex medical devices. So he needed a code that he hired 5 consultants to do it. Say, let's try it. He put the code into ChatGPT. In a minute, it spits out a phenomenal C++ code, self-documented. He says, I'm going to show it to the team and send them home a day later. It's all done. It's unbelievable. You want a Python code that's there, ChatGPT will do it for you. So how we teach now analytics and programming when the machine can do it for me? It's a very interesting question. Amazon, digital pharmacy, supply chain, personalization, AI is everywhere there, okay? Mayo Clinic is huge effort. They have partnership with Cofactor, K-Health, Vuno Diagnostic, many others. They have a center for individualized medicine. They focus how we use AI to get better outcome. Not physician by physician, but from the CEO down to the corporation. They compete, and they want to compete well. Cleveland Clinic, just in January 23rd, okay, they say, we're going to improve hospital operation through AI command center. They're making a huge effort, trying to kind of change the way they manage all the patient flow. Which beds are empty, who is going to be discharged, who is going to get an expensive exam, etc., okay? Another example is Cedars-Sinai in Los Angeles. The future of medicine lies in decoding enormous amount of phenotype and genotype patient data. So people who get now degrees in AI will be hired by all these companies who develop an AI R&D center inside, where they combine and assemble an orchestra of tools to get what we call the process impact, the end-to-end, the system-level outcome of AI. Summary conclusion, as I say, lack of human touch, responsibility issue, reinvestment, how to show real value to many cool AI applications, undue societal pressure. We expect it will never fail. It will always fail, okay? Concern about bias and discrimination. Again, men do it, women do it all the time, physicians do it. We expect message to be neutral, but nobody knows what's the right benchmark. North America, South America population, Asian population, the whole globe, because the more diverse you train the system, the less accurate it becomes. You have to remember that. We have to move from point solution to system solution. And bear in mind, the race is on. The question is, what do we do here at BU to capture the wave and to lead the thought process? Thank you very much.
Maya? Okay. So thank you very much. We'll take a quick break, maybe 10, actually about 10 or 15 minutes, get some coffee, do bio breaks, do what you need to do. And then we'll come back and we'll have our roundtable panel discussion with our speakers, 2 guests, and my co-host, David Epstein. And I'll try to moderate. Please, in the audience, scan the QR code. The audience online here we can have live questions, but anyone online, please submit your questions to this polling system, and we'll try to direct the conversation accordingly. So thank you very much. We'll see you in about 15. Okay. We missed, oh, Ivy will be right back. So we can start without him. So to start, you haven't formally met Maze and Michelle. So I will let you can take this mic and introduce yourself, a little bit about what your research is, and then we'll get started.
Yeah, thanks, Pete, for the introduction. Hi, everyone. I'm Mei Zhou. I'm assistant professor from the Information System Department. My research interest is on using algorithmic and econometric methods to understand IT-enabled platforms such as recommender systems or healthcare platforms. So, like, for example, one of my work on the recommender system looks into how does the bias of humans impact the performance of recommender systems in the algorithm and the human feedback loop. That's one stream of my work. And the other stream of my work is on the healthcare. So I have a work trying to look into how does the telehealth technique impact the rural and the urban providers' services and their financial outcomes. Yeah, so that's a quick introduction about myself.
Hi, I'm Michelle Schell. I am a visiting assistant professor in the Operations and Technology Management Department here at BU Questrom. My research is, I like to say anyway, looking at the operational costs associated with human emotion. And what does that mean? I'm particularly interested in how humans, whether it's customers or employees, respond to operational design choices that companies impose. So if we think about as customers, how do customers interact with self-service technologies, for example? How do employees interact with, apropos to today's conversation, the introduction of artificial intelligence systems as they're doing their work? So a couple of examples of the type of work that I do. And the methodology that I use in doing the work that I do is experiments. So I run laboratory experiments, and I also work with companies to conduct field experiments as they're thinking about deploying these technologies.
Excellent. Thank you. Okay, let's start. I know there must be lots of questions in the live audience. Please.
Hi. Good evening. Really glad to be here and thank you for all your time. My question is actually for Mr. Jivan. So we were talking about the different football fields and the veterans, kind of the data that you're pulling in.
Yeah.
And we spoke about the variations of the forms that you get in.
Yeah.
As someone who's designing these systems, how critical or how difficult is the trade-off between seeing what the user might want to do versus your intake of data? Because if you try and control that, that might be a way to restrict the number of forms that you have to kind of make these operations on and might make it more efficient. But we were talking about how you think about it from a user perspective and what they might be into. So how do you kind of see what kind of that pain point? Where do you make that decision, where you draw that line between what the user might want and what might be good for the system?
I think the way to look at these problems is break it down into smaller chunks, right? You have an end vision of what your user experience should be like, but then you don't want to go after all of those improvements in user experience on day one. You have to work backwards from that and break it into smaller pieces, right? So with that example around the work that we did with the VBA, what we ended up doing was we tried to first understand the current state process and understand what are the form variations that are causing the most backlog today. Go after those ones first, and then continuously keep adding additional forms that would then improve. At some point, you'll reach a marginal utility, right? The addition of increasing an additional form might not significantly save you hours or dollars in terms of cost savings, right? But initially, you will see a significant savings. So go after those high value ones first, and then slowly, continuously improve. It's an iterative process. So that's how you always do it. Break it down into smaller chunks, and after always start with where the biggest pain points are, and then continuously improve it.
Are you doing that? Are you sort of applying the 80-20 rule essentially, and looking at the 80% of issues and rather than, because those are the forms that you're managing 80% of the time, as an example?
You could say 80-20. You could, I mean, honestly, there's no hard metric. I think what I would say is go after the ones that has the significant value proposition. And if you are trying to improve user experience, then go after the ones that simplifies the process the best, most easily. I think somebody also talked about the trust in these systems, right? So if you go after something that in a way destroys the trust, if you go after a use case initially that actually works against you from a trust perspective, you're actually like going against the adoption of these systems. So in a way, you have to balance not just the value proposition, but also, can I implement something that I can firmly stand behind, and also that can improve the adoption and trust of that system that can continuously improve.
Where I could add, I could add one question I saw from online, plus my own question, plus I'm sure the rest of the panel would add to it. Trust in systems. I mean, it gets to what is the, in your experience, Jivan, but also from others' perspectives, what's the augmentation factor with humans, right? In getting humans to use it, and what are the, methods to improve on that? Michelle, you like to?
So one of the projects that I've worked on is with a call center, where the company was using artificial intelligence to effectively coach the agents on the phone as they were interacting with customers. So there's been research, and I think Gordon mentioned research, where AI is interacting directly. AI is interacting directly with customers, and there's a sense around deception. There's a feeling of being deceived. Their customers may seem to be repulsed by that. In this research, we augmented. We had the AI actually working with the human agent to deliver satisfactory service to a customer. And what we found is that the calls where the AI was coaching were far more efficient. And on top of being far more efficient, so about 30% more efficient, we didn't see the aversion that we expected to see from the agents. So the agents were actually more likely to comply with the script that the AI was delivering versus the agents that didn't have access to the AI, but had access to the script. So the calls actually ended up being more efficient, and the interaction with the customers was actually of higher quality. So customers actually, those calls had higher levels of rapport between the agent and the customer.
Anyone like to build on that?
Trust is a tricky business, okay? And you don't want it violated. Look at a married couple. You lose the trust once, the marriage can be broken. But in business world, we do a lot of repeated decisions. So if you look at medicine, which I talked about earlier, physician, if you put a gun to the head, how does aspirin work? They don't really know. But they trust it. Because there's a phenomenon, we call it seeing is believing. They've seen it done on thousands of people with minimal side effects, and they keep giving it. But they also know that the old model, if you take a baby aspirin every day, over time cause side effects, and they stop recommending it for healthy population. So over time, we learn, and our trust changes as we get more data. But in many, what we call business-like or medical, repeated decision-making, a lot of it is seeing is believing. If it works, I'm going to use it. And I'm not always sure why it works, but so long as I don't see harm and it produces superior results, I'm going to take it.
One thing for me that I typically like to add is it really depends on the complexity of the systems that you're trying to put in place. So, and what I mean by that is you have to always stratify the decisions that you want the AI system to make. Are they really making a medical diagnosis? Like, are you saying that's a very risky business in terms of like making somebody's health decision, versus are you making a decision on, I don't know, extracting some information out of an invoice for back-end processing, right? So as you look at these trust and responsible AI practices, the first step is stratify in terms of the risk that the outcome from the AI system is going to give to you or to customer or to your business. And then depending on that, the bar needs to be set accordingly on what kind of guardrails will be placed to whether it is the model training, whether it is model implementation, whether it is model monitoring, all of those processes accordingly. So we do see that when I mentioned early on, the first step is like vision. Really, that is where all of these needs to be discussed and decided. And that is where you need to have probably a combination of not just technologists, but also like legal ethics people in the room with you when you're making those decisions.
Can I just add one thing?
Yes, Gordon, please.
Yeah, so I think a couple of the answers, so Michelle, Jivan, speak to like a higher order thing, which is context matters. So what is the AI doing exactly? Like I may have faith in it to accomplish one task and not another. It also depends on our arrangement. So like, do I perceive that the AI I'm interacting with has aligned incentives with me, or are we somehow in competition with each other? So is it helping me do my job, in which case everybody's incentive is for this to go well? Or is it a customer service rep where like, I don't know what objectives it's programmed to accomplish necessarily because I don't work for that organization. I don't know how it was set up. I don't know who developed that thing. I don't know what guardrails it has. So like a lot of it is context dependent, I think. And that's an important thing to keep in mind with any of these systems. How a consumer is going to react or how a user, like an employee user is going to react could be quite different.
Excellent. And maybe building off that, we have another interesting question. And the question, I'll read it verbatim, but I think we need to interpret a little bit. Will decision-making, quote, strong AI dominate the future, or will we mostly employ specialized, but and they quoted weak AI? So I think the question is, somebody touched on verticalization of AI, right? And that trend in future. Is the question, right? Are they by nature weaker, or is that the future, or are they stronger? Or what other implications does that question hold? We'd like to start. Meze, any comments, or DK?
So just to clarify, strong AI is a term described to mean artificial general intelligence. Weak AI, more specialized, not AGI. I mean, who knows when the strong AI will come, right? So people have been making predictions for the longest time. But when you ask, I mean, I think it's we wouldn't know. I don't think when that would come. So I think it's a question that's not something that we have to worry about right now. Is like impact of weak AI, right? And I think at the for the next few years at least, these weak AI or specialized AI would dominate, and we would have to figure out how human how humans would collaborate and with it, use these as a tool, as an augmenting different task, and things like ChatGPT or other these very capable AI machines, how they fit into our roles in this, companies' everyday process. So yeah.
Yeah.
I think, when we think about new technologies, there's the state of the art and then there's the state of the market, right? Like the state of the art it could be all of the whiz bang functionality that we could ever dream up. But if we're not able to use it effectively, or we're not willing to engage with it in a way that improves or meets our goals, then it doesn't really matter, right? So the project that I was referring to, I think would be considered weak AI, right? And so if it were strong AI, like the AI was, or the agent had a fear that this AI was better than them, right? And so therefore could replace them, then perhaps we wouldn't have seen the uptake that we saw, right? And we wouldn't have seen kind of the improvement that we were seeing in terms of the service that they were delivering, right? So I think there's balance that has to be struck as we're deploying these technologies. We don't want to induce fear, and therefore, or induce kind of deception, the feeling of being deceived or the feeling of being manipulated. We want to make sure that as we're deploying the technologies, we're meeting ultimately the goals and that it's palatable.
Yeah. I think what you mentioned is the call center. It's more what I would call a point solution. It's an important point solution. And some of the people in the call center may say, okay, God's technology, people come with chat and knock us off. But there's just as a caveat to the question you asked, Pete, as time goes by, we delegate more tasks into AI. That's all across the board. But look at flying jet planes, okay? For the last 20 years, we have a function called, I used to fly in the Air Force, so I know it well. It's called auto landing. When you can't get into any North American airport with all the navigation, unless the weather is very bad, the machine lands the plane. However, the rule is that once every 5 to 7 landing, you have to do it manually. Why? To keep the skill in case the machine breaks. So there's a balance between what do I want to take from the person and what skill set I need to keep just in case. That's true for politics, for military, for anything else. Yeah.
Yeah, I'd like to go back to Michelle's example and look at it from the customer standpoint a little bit. And that is, so with the weak AI, then from the customer standpoint, they're also speaking to an agent or speaking to a human, and that builds trust on that side. Once we get to a strong AI, where it's able to, be responsible to be able to be actually answer the questions and deal with the individual, then maybe we get to a point where you trust that AI because it actually does handle it the way that you want to. But that's the big leap. And then your agents aren't going to be very happy, of course, because they're going to be, reduced out of a job, if not out of a job. I don't know how many of people get on an automated voicemail system, and the first thing you say is agent, 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 right? Because
but most of them are poorly designed.
Yeah. But
And when it comes to my accent, they can't help me.
but it's it's interesting though that the Michelle's example of that, even when you're talking to an agent, you're actually talking to the AI. Yeah, through an agent. So.
Following up on that example that you just gave, actually, so doing conversational AI is an interesting challenge, and the question becomes sort of how much does the AI take over versus, as a handoff to the human. So in healthcare, there's a lot of call centers that are either receiving calls or making calls on behalf of an organization. A lot of staff is being used, very high expensive staff is being used. And you gave an example earlier about, call centers. So the question that I have is, and I have personal interest in this because it's part of what my business does, is using conversational AI. What are the barriers or what are the risks, especially given some of the comments that you've made, in terms of making sure that the person that's talking to the AI doesn't say, I don't want to talk to them. I want to talk to the live human. Questions like, directions and location and hours and basic information that is easily accessible that they feel comfortable with, or the outbound call that's that asking them questions about their recent procedure. And if they say, I want to talk to the nurse, no problem. We'll transfer you to the nurse. But gathering the data to enable the provider to do their job more effectively at a lesser expensive cost and leverage that nurse for tasks that they add value to, and they don't adding value by making a phone call in most cases for normal conditions. So I'm just curious, how do we get that adoption curve to be improved without alienating the patient and improving operations?
Okay. We do a lot of work with payers and providers, right? What we build is a single AI system that serves not just your members, but also your agents. So because both at this are accessing the same knowledge base at the end of the day, right? These articles, right? So typically when you have a client call you, or a patient or a member call the call center, the idea would be to handle that transaction and contain that call with all the information. And typically most of the calls are transactional calls that can be, if the voice, to Ari's example, is a problem, we can immediately digress that call to a chat. And between chat and voice, you can continue that call to handle that transaction. Those systems are very much in place in production today. And if in a scenario where I would say, give me an agent, what that would have, the scenario today is we would gather the information, but then the agent itself, the AI agent, becomes what is called as agent assist. On the back end, it transfers to a human agent, but the human agent really has a chat window that not just gives the full information, but also gives recommended actions to take for that particular member, along with the longitudinal data, if any, associated with that particular member or patients that the agent was able to pull from your ERP and other systems on the back end. So all of these are very much live today. There are a lot of providers that are already doing this, and we have implemented a few for them as well. I think this, I do not see any issues with agents or even providers like patients using these systems, because honestly, where I see a lot of use for me, like as a patient, for example, I am on Tufts Medical. If I'm always looking for an agent to talk to, I would only have to call between 9 and 5. that's a challenge for me. I would rather call in 1-800 number at 11 at night when I'm available and continue to do my transaction. That is only possible through some of these AI systems while reducing the operational costs. So I think it is here to stay, and it will continue to see broader adoption. I honestly don't see too many issues, at least in some of these. I mean, there are definitely systems where the data behind and the data that is handled by these systems have to be HIPAA compliant. And there is a higher level of bar for some of those systems, but it's definitely already in progress for sure. Sure, others have.
So on another project that I've worked on, we were looking at the value of human contact, in particular when people are feeling anxious, when customers are feeling anxious in particular. And what we found in that research is that from psychology, I mean, we all experience this, that when we're feeling anxious, we really want to talk to someone. And what we found in that research is that we were having people use self-service technology, and they were making decisions. And we found that when people were feeling anxious, they were feeling very dissatisfied with their own decision-making, even when the decisions were in line with their goals. They were just simply unhappy with their decision-making. The anxiety overwhelmed because of the anxiety in this case was coming from that uncertainty, and it overwhelmed their satisfaction, their ability to make decisions that they felt good about, even though the decisions were in line with their goals. And we found that dissatisfaction with their own decision-making spilled over to affect the trust that they had in the company, even though the company actually had nothing to do. All the company did was provide the platform, right? And so to your question of like, how do you, where might the cost be? The cost might be in that loss of trust, particularly when if customers are feeling anxious, if it's a high stakes decision, if there's information asymmetry, if the stakes are high and there's uncertainty in the outcomes, that may be a place where the technology isn't as helpful, where the human contact is necessary, or at least the idea of human contact. So one of the things that we found in the research was that they didn't actually need to interact with a person to overcome the effects of the anxiety. Just having a chat button was enough. So knowing or feeling as though they could reach out, whether or not there was actually a person on the other end or a chatbot on the other end, they felt as though they could reach out to the company, and that was really important. So my point here is that even though we're deploying these technologies, and in deploying the technologies, we're kind of reducing human contact. Even in that case, it's still important when we're operating in high anxiety settings that we reintroduce these notions of human contact. And that kind of touches to the idea of how humanized do we make some of these technology deployments.
I think that one of the these things that this brings up is really transparency. I think that if when you call in, you know whether you're talking to a bot or an agent that's using a bot, or an actual real nurse or a real doctor, has a whole different effect. I think that many people are not sure when an agent answers. If you're asking a medical question, you kind of question, well, who is the person that's giving me the answer? I mean, if it's somebody who's just maybe out of school and the first time they're answering calls, you may want to talk to a bot, which has been trained over this thing instead of that. So I think that the idea of transparency and making sure that people know who they're talking to and where they're getting the data from, especially in a medical situation, is builds the trust.
Let me just give another dimension. The most natural way of us communicating is by speech. We were not born to type or to read or whatever. That's something artificial that probably will disappear in 20, 30 years. But one has to be very careful with making general conclusions here. We've done some studies on people making investments in times when the stock market gets highly volatile. And you see a very clear demarcation age-wise. Individual over 40 years old would like to talk with somebody. Those below 30 years old, if you give them phone number, they get upset. They don't want to talk. They want to use WhatsApp or chat or text messages. They have no tolerance to talking with anybody. They're not in the mood. They don't want people to listen to them. So it's not one size fits all. One has to be very careful. And of course, 40 is just artificial boundaries. So different individuals need to communicate in different ways, and we need to provide them that channel, because their trust and their social habits are, they don't talk with the friend, they chat with the friends. They send text messages, and every generation communicates differently. So it's extremely important to kind of recognize what the consumer wants, not only what we want to deliver to them, which is a big part of the system design.
Since we are on this topic, just one company to keep an eye out is this New Zealand-based company called Soul Machines. Have you heard? Anyone heard of Soul Machines? Yeah. These are the founders of the creative designers behind Lord of the Rings. They designed a lot of the graphics behind it. What they're doing now with the startup Soul Machines is they're putting faces to these conversational agents, right? So we are just talking about voice virtual agents, right? How do you modulate the voice? But think of an avatar that sits in the front. And then that avatar can change depending on me versus Ari versus Michelle, everybody else. And the face and the emotions, the eyebrows, depending on the type of conversation, can change. And they have done some fantastic studies around the world and how it actually, just putting an avatar can actually have an impact on smoking cessation programs versus a voice program. So just keep an eye for this. This is an area of like so much rapid change that I would be very, very promising area for sure.
Now the ethical question comes up
Yes,
is there an echo chamber here too? That now you're only going to trust somebody that looks like you, and what does that do to us?
Huge implications. Hey, so yes.
But I have one in this area that I want to ask. So we hear a lot about explainable AI, and I think Avi brought up this really nice point about how maybe that's not enough, right? You could have two judges that have different opinions and maybe their explanation is only part of the story that's going on. Another way of saying that is, as humans, we trust, and I'll use that word, experts in certain circumstances, and don't necessarily evaluate their expertise solely on their explanation, right? There's a trust that's implicit there. And a lot of that comes from, if you kind of step back and give it an ML lens, interpolation versus extrapolation, right? We trust that this person is an expert because most of their opinions are coming from an interpolation. The support of the data that they're using to draw that conclusion is close to the question at hand. And we don't have a lot of explicit explication by ML agents about where their support actually is, and therefore where their level of expertise is, and therefore whether we should trust them or not. Is a sort of general critique and statement about the current state of ML. And it's not really therefore about, or this I'm postulating here, maybe it's not therefore about explainability per se, but about a certain amount of transparency about and communication about and dialogue about where the ML's expertise actually lies. Where is the support of its training? And you can think about this in these kind of call center cases, right? I'll call a company, Comcast, and tell them that I would like to have a dialogue about my modem. And I'm put into this, to Avi's point, maybe not perfectly well designed call center structure. And I, as an end user, I would like to claim of some sophistication, immediately know that my problem is a 99.9% percentile problem. It is not covered by the 80th percentile case that this AI has quite rightly been designed around.
And yet it can be very hard to convince the AI system that I, in fact, know better than it, and I should get to the agent right away. And so, what's the net result? The net result is that I hate Comcast forever and ever. And so my point here is that this is a tricky space, and I was just hoping maybe the panel might respond.
So I have an initial thought here, which is that I would push back a bit on how different this context maybe is between faith in what an ML is telling you and needing explanation and transparency versus an expert. Because do you really know that the expert is an expert most of the time? Like, it usually just comes from other cues, like other people trust this person, so I will too. And maybe it comes from, I don't know, you have a degree, which means somebody else verified you. I didn't verify you, but I trust somebody else did. So I think a lot of this may actually be normative. And over time, as we gain more faith in the abilities of the technology, as the technology itself improves, eventually you will see a shift towards a default of trust. Actually, it's just that we're not there yet. And even your Comcast example, like if I get the wrong human agent on the phone, I think I know better than them and I can't convince them. This is called Dunning-Kruger. Right? Who's right? I don't know. Right? But the point is that I think trust, whether it's in technology or another human, regardless, like most of the time we don't have the resources or time or bandwidth to verify everything. And so it gets black boxed and we figure out some heuristic. I think when you look at it that way, actually the processes are not that different from each other. That's my perspective. 2 cents.
I think I can add a little bit to that question. I feel like sometimes even if the result of AI does not include any explanation, it can influence users' decisions to some extent. So for example, when you look at the prediction of a recommender system, even though it didn't tell you how the algorithm ran, it didn't tell you what kind of information it used to generate this recommendation, you are more or less influenced by this recommendation provided by this system. It could influence what kind of movie you watch. It could even influence, like after you have already watched this movie, you already know what the content is. Your submitted rating, your feedback could be more biased toward the system's prediction. So that is like we call it anchoring effect. There could be other reasons, but sometimes it's unavoidable. And in like if you consider it's not like a one-time thing. Actually, your feedback that is influenced by this AI will be submitted back to the system and will further influence the AI's prediction or the AI's decision in the next round. So it is kind of, it will be accumulated or like evolve in this feedback loop, and it can I don't know, maybe influence a large scale of population. So like when people trust the AI's prediction, sometimes it could be a problem for the AI's performance. Yeah.
Can I ask the panel a question? Okay. It's a two-part question and I'm seriously deliberating it. Part one is, should we change the way we teach physicians in the United States, cut on the wet labs, the microscope, cutting the frogs and whatever, and give them more digital know-how? And second is, what and how much AI should our MBAs have when we graduate them? How much AI we should teach or impart on our MBA students? What's the minimum they should know as they go to the market next year and the year after?
So I don't know too much about the medical part. So,
okay, so that's why you have part two.
yes, part two. So I think MBA, well, knowing all, I mean, I would argue that knowing the algorithmic details important, but that's not for everyone. So I think at the absolute minimum, MBA students should be able to sort of have an overview, understanding of how technology work, so they can tell if someone is just speaking nonsense. There's a lot of these like BSing going on in the world, right? especially with the AI and people with no knowledge just getting sold on what it can do and what it cannot do. Another thing that I think we need to instill in an MBA education is what could really go wrong if you don't really think about how these AI systems are deployed. Like back in, I think a lot of people know about how Florida justice system used AI, and it just turned out to be making very racist decision, not because it was programmed to do so, but because it was trained on biased data set, and it's just reflecting that. And the big thing here is that racist judge could ruin the lives of 1,000 people or whatever, and that's terrible. But biased algorithm can ruin the lives of millions and billions in an instant. So I think at the very least, two things. Teach them enough to know what is possible and what is not possible. And second, give them ideas about what could go wrong via some cases and critical thinking on that. I think that's definitely needed, at least those two.
That was the venture. I think I wouldn't say that we need to completely revamp what doctors. I say this with no knowledge of the U.S. healthcare system, but I'm just going to say it because why not?
It's a future patient.
That's might even not be true. I might just move away. So anyway, I think to the extent that the technology is being integrated into healthcare practices, they should know how to use the tools of the trade. So this is going to be happening in the next few years, to the extent it can augment their abilities in certain roles and tasks, it makes sense to incorporate that into education. That said, it's in many forms of medical practice. I gather it's a highly specialized practice, and so you need to know a lot of the inner workings, but that's my uninformed opinion on this. And then as far as what to teach the MBAs, I've actually taught MBAs AI, so it were. And so my view, and I've even talked about this at your teaching workshop in the past, Avi. My view is that our goal should be to make MBAs conversant on a lot of different things, right? Because it's like a general purpose degree for the most part. And so the idea is what do we have to teach you so that you don't look like a fool in the boardroom? So essentially, you should have a BS detector, like DK was kind of saying. We should have some ability to evaluate what we're hearing about and call out things that are incorrect or don't make sense. And that might mean understanding very basics of process, like ML ops, right? So this idea of what's involved in building a pipeline of any kind of predictive model. I'm not going to teach you a specific algorithm, but general rules of what is model evaluation and what's the basic ideas about how these models generate prediction outputs. And so they need some reference point to draw on to ask the right questions, is what I would say.
Let me push it a little bit. The two answers we got so far were very good, but they were on the passive side. It means when you buy something, check that you kick the tires. But if I want somebody who comes out as a business leader, what should they know? What's your answer here? You work with business leader, people who initiate things. Not just buy something and say, okay, the boss told me to install it, but how do you generate the vision so they'll come and push things? What's been your experience?
So I'll take the second question, which is on MBAs, because I absolutely do not
Easy
have.
one.
Yeah, okay. I do have an MBA, and I honestly think I am of the firm belief that every MBA student should learn how to code, minimum. And there is going to be a democratization of tools that will make it more broadly available. But having a fundamental knowledge about coding and understanding how things work under the hood is something that our academic institutions have a fundamental role to play, right? Can things evolve? Yeah, I mean, I started a career that is completely different than what I am today, right? Careers can evolve, careers can change. But that learning and the intellectual curiosity is something that I firmly believe. So to answer your question, Ari, yeah, I think those are the kind of things that I look for when I seek talent from schools is, do they have a firm grasp of something? Are they passionate about something, right? Is it policy on AI? Is it legal implications? Is it responsible AI? Is it something? Do they have at least one grounding on one coding language? It could be Python, it could be SAS, it could be R, doesn't matter, right? Do they have the intellectual curiosity to learn something new? Because every day they will learn something new. So those are the kind of traits that I look for, whether it is an MBA student or a BBA or an undergrad. Honestly, it doesn't matter.
Yeah, I want to come to this little bit on the same side, but so at Stanford, every single student has to take a coding class. That's required. So they take a coding class, and they learn Java or Python or one of those. But coming from an engineering standpoint, though, when I studied engineering, all the things that I learned in school were useless on about a year or two afterwards, right? Because anything that you learn is outdated, and I think that's going to be true of AI, how it works, how it's going to be things, and certainly programming languages and such are going to be outdated. But what we learned is how to think, right, and how to repair things. I think that for MBAs, they have to be taught how to think, and in particular, have to have critical thinking skills so that they don't just blindly trust the AI or anything that they're any device or anything that's automated for them, that they need to verify it. They have to learn, how do you verify it? How do you make sure? How do you monitor the results? How do you come back that you may not know how it happened, but if you look at the results, you look at, is there bias in your data? Is there in finance, we always do that, are people buying what we're selling, right? And if they're not, then you have to fix something. If the AI is producing something that as a result is not producing what you expect, you need to be teaching the students to look at the results and be critical. Yeah, and assess them. That's the thinking that has to happen.
So final wrap-up question. And by the way, we had online audience question, which I think you all kind of addressed in the MBA section of Avi's question. And the online question was, given that we know that AI will free up employees for higher value work, quote unquote, give us some examples. What is high value work? In the interest of time, we could probably talk all afternoon about the in-depth issues, but I think we addressed, at least with MBAs, what that means to be ahead of it, to be understanding it, to be critically thinking. What I would like to do in the last 7 minutes with 7 people, lightning round, what are the 1 or 2 things you would advise business to do in the next year or 2 relative to AI and customer or patient engagement?
Sorry, what's
what are the recommendations you would have for business around this topic? What should people start on tomorrow?
I think the biggest hurdle that companies that I work with or advise have problem is actually just getting the data. Well, they do get a lot of data, but it's all disconnected, and it's all about making data connected, usable. So I think that is the first and foremost. A lot of techniques are actually commoditized, and in real world, in production, ML ops is the least of the concern. It's about data and making sure things, it has signal. So I think, yeah, data collection, fabric, making sure that things are connected.
And I think another thing the business may want to think about is how to react to the current data privacy policies, such as the CCPA, GDPR, those type of things. Because nowadays, it's not just about collecting data freely. You still need to consider the customer's rights, and this policy kind of trying to give the users more control over their own data. Then one question for these companies is, how do we develop the techniques that can satisfy this policy, but at the same time maintain the performance of their business? Like like in the recommender system, how do they maintain the recommendation accuracy and in the meanwhile protect users' data privacy?
So as DK said, I think a lot of the tools and techniques are a bit commodified. Like you can outsource several of these things, right? We could hire IBM to develop a lot of these things for us. The stuff that you can't really do as well on your own. And that's not to say you shouldn't do that, right? But the things that you may not be able to do quite as well on your own are softer things. So like, what are the cultural shifts that have to happen internally at the organization for the things that are purchased and implemented to stick? Right. And that may require, broad education across the organization. Everybody in there should have at least some understanding of what the technology is and maybe what it can do, because a lot of the ideation and thoughts about what could be fixed, what could be made better, or where investments could be going to create new options and new services is going to come from the employees who know the business the best. So educate them first.
Almost took the words out of my mouth. Do a lot more. My advice to businesses would be to do a lot more testing internally with their employees before deploying out. So when we think about customer service in general and getting value from services, it really starts with the culture and of the organization and employee engagement. And so I would say that as they're thinking about deploying AI or testing AI or understanding AI, that they spend a lot more time internally understanding what it is, how it's being used, how it's going to impact the culture of the organization, and therefore how it's going to impact their customer engagement.
I would recommend, thank you. When I talk with leadership of businesses, it's 4 things. And I will start with the rule I learned at the Air Force. It says, look around, the one you don't see is the one who's going to shoot you down. So first, educate yourself about AI. Second, develop a team, give them budget and give them the mission to rethink how the business would look like if we started today with AI. And don't go for point solution, by ask yourself, if somebody will start a business school today or a hospital today or an airline today, how will they do it if they have all the AI we have today and tomorrow? So rethink the business from scratch. And the fourth thing is always be on alert, because competitors will have ideas you never thought about. And you have to look around all the time, because there are a lot of innovations that if you miss, it's too late and your business can be over before you think about it.
Honestly, I think they all covered most of the points. So I'll take a little bit of a different spin around trustworthy AI, right? I would like to see more and more businesses going towards adopting AI labels. So think of our food labels. Everything that we purchase has a food label that tells sodium, fat, everything. There is an effort in some parts of this AI community around creating AI labels to improve transparency, to improve trustworthiness, explainability. I would like to see businesses creating AI labels for every system that they deploy that can be very, very transparent. It will happen soon, but I would like to see that happen faster.
Finally, I guess. I think that from my point of view, from an ethical standpoint, I think it's necessary to convene committees or executive working groups to make sure that what you're deploying has the consequences that you want, and watch out for the unintended consequences. So actually have people who think about that, not just go blindly into we're going to fix something without thinking about the unintended consequences, because those bite society every day.
Well, fantastic. Thank you all very much. Thank you, audience here and online. I think with that, we'll wrap it up. So thanks for your attention. Thanks for your participation. This will be on video. We'll be publishing it on LinkedIn and Instagram and through Equestrium Insights Equestrium. So thanks again.